hold up the program any longer because I know Mr. Van Wyk is joining us all the way from New Zealand. And like I said earlier to him, I'm saying good morning to him for us, but it's actually good evening down there by him or up there by him. So thank you very much for joining us, to everybody online and to those of you with us here physically at the day 2 start of our Architecture and Design Build Expo. So first up on the program for workshops today, we have Mr. Llewellyn Van Wyk. He's going to be talking about, let me just get the title here so that I don't get it wrong. It is Science, Engineering and Technology for Building, a case study of the Albertina Sisulu Science Center in Kulumbimba. Right, now if you do not know a bit about Mr. Van Wyk, he's the principal researcher at Urban Lab, a research-based consultancy focusing on resilient and sustainable urban development. He retired from the Council for Scientific and Industrial Research, a Smart Places unit in 2019 as a principal researcher. He lectures online at the University of Johannesburg in the Department of Mechanical Engineering Sciences. He also tutors postgraduate and master and doctorate students in New Zealand. He holds a Bachelor of Architecture and a Master's in Science, cum laude. Mr. Van Wyk is a researcher, guest lecturer, and designer with extensive international experience. And most importantly, he is also one of the co-contributors to CAD4ALL's new qualifications, the NQF 7 degrees. Right, so without further ado, over to you, Mr. Van Wyk.
Thanks, Ryan. Thanks for that introduction. Welcome to everybody there. I'm very pleased. I'm very pleased that you've invited me. Firstly, it's a thrill to participate in your conference and exhibition. And then at another level, it's even though it's virtual, I'm kind of back home because I'm born and bred Cape Townian. So it's a double pleasure to share the next 40 minutes or so with you. So I'm going to take you through a project that I did while at the CSR. We were approached by the Department of Science and Technology, who were interested in developing a science center in the Eastern Cape. And initially the discussions were around, could we help project manage the project, which then grew into, well, how do we go about making sure that we introduce some interesting technologies to the building? And that eventually landed up in a discussion between myself and DST about, hey, why don't we actually make the building part of the science center, part of the science? So instead of just having a building with exhibits in it, the building itself becomes an exhibit. And they found that an exciting prospect. And so we proceeded on that basis of saying, let's roll out whatever we think is feasible in this building. And also gave us the opportunity as a CSR, as a research council, to begin to tease out what sorts of technologies we could apply, what their efficiencies would be. And so for us, it became a bit of a laboratory in a way as well. And all kudos for DST for buying into that and saying, look, if it doesn't work, it doesn't work. Obviously, we'll do our best due diligence to make sure that it would work, but they were open to the prospect of us testing and trialing things that hadn't necessarily been done before. For my own sake, from where I come from, sustainability is a non-negotiable. So the graphic on that opening slide is all about how do we develop our built environment in a way that it's in fact sustainable and increasingly becoming resilient in the face of climate change. So this is the story of the building. So just to give you some little view of the presentation structure, I'm going to talk about very, very briefly, we don't have a lot of time, the infrastructure climate change nexus, why infrastructure development becomes such a crucial component of dealing with the climate change challenges. And then a potential solution recently covered in the IPCC reports around nature-based solutions, and then science, education, and technology for building, and then take you through the building and just come up with some conclusions. So I like to start with this. I do this with the students at UJ as well. It's a statement by Zia Qureshi from the World Bank, And it says, today, both infrastructure investment and climate action are urgently needed. With the right approach, we can achieve both goals simultaneously, building a more prosperous and sustainable future. And I find this an incredibly optimistic and exciting prospect. How can we, in fact, do this where, in the effort to overcome infrastructure backlogs, we can, in fact, also simultaneously deal with climate change challenges? And the key word in the sentence is that, the right approach. And then that is the question, what is the right approach? And the rest of this presentation is an argument that I make about what that right approach could potentially be. There is a real reason for focusing on infrastructure. We know that over the next 15 years, more than 90 trillion in infrastructure investment will be needed worldwide just to overcome backlogs and deal with failing, in many instances, failing infrastructure all over the place. And you guys in South Africa, my own experience there, don't need any reminding of those challenges. But this is more than twice the value of the entire stock of infrastructure in the world today, just to give you a sense of scale, and requires an investment of something between 2.5 to 3 trillion above what has been spent to date, to above 6 trillion if we're going to cope with meeting the demands. But here's the sting in the tail. Infrastructure alone accounts for around 60% of global greenhouse gas emissions. So if we proceed down the same path, if we develop our infrastructure using the same paradigms, then we're going to land up with increased greenhouse gas emissions, which kind of defeats the purpose at the end of the day anyway. And so this issue of how do we meet these backlogs, these societal requirements for infrastructure, without pursuing the same climate impacts as we have been doing in the past. And give you an example, the illustration is Hammersmith Bridge in London. It's over 100 years old, predominantly made from cast iron. And due to the heat waves that they experienced a couple of months ago, the cast iron metal components of this bridge started fracturing. Hairline cracks and internal material fractures, to the extent that they actually had to wrap up that entire bridge in insulation to help keep it cool. So that's one piece of infrastructure in one city in the world, and there'll be any number of examples like this that are going to find it increasingly difficult to cope with climate change impacts as you're going forward, whether it's extreme heat or extreme cold and everything in between. So there's real cause for concern, not just about what we do to the existing infrastructure, but particularly how do we handle it going forward. And this is where nature-based solutions comes into it. If you look at the nature-based solutions initiative, essentially they are defining it as actions that work and enhance nature so as to help people to adapt to change and disaster. So the argument is, can we use nature-based solutions, or can we essentially use nature as a co-development partner? And by adopting that approach, we will avoid the pitfalls, the ecological and climatic pitfalls that are typically associated with development. The initiative also recognizes hybrid solutions. And so if you read the IPCC reports, when they talk about nature-based solutions, it's forests, it's mangroves, it's coral reefs, it's the real, what the initiative calls type 1, real gutsy kind of ecosystems. But they see space for hybrid solutions along a gradient, and I think that's exciting. And so they've introduced this idea of type 2 and type 3, and it's particularly the type 3 that I find of great interest, because in it they include greening cities and by implication greening buildings. So that what the work that we do as environmental designers, as architects, can in fact begin to fit into the broader palette of nature-based solutions, and extending that further, recognizing the role of infrastructure, using ecosystem-based approaches to deliver this, meet the societal challenges, whether that's water, whether it's energy, food, whatever it is, and ultimately achieving a double whammy, meeting human well-being or improving human well-being, while at the same time reaping biodiversity benefits. So that question of the right approach, developing infrastructure and meeting climate change, is in fact then hinges on co-opting nature as a co-partner in the way that we build and design our buildings. So getting to the actual building itself, the objectives from DSD side was to promote the awareness, understanding, and appreciation of science and technology in society. That's their mandate, is how do we extend science and technology into governmental systems, into schooling systems, and into the broader society, and provide curriculum support for math, science, and technology, advance education, nurture talent, and promote literacy. So that's their mandate. And the aim of the building is to facilitate the exercising of that mandate. So there were programmatic requirements. We needed some parking area, an arrivals forecourt, the typical stuff, a foyer reception, a lecture room, which we then turned into a planetarium as well. Clearly, you need some administrative offices and staff facilities in the workshop so that you can deal with some of the exhibits, dismantle them, erect them, and change them, and so on and so forth. Crucially, in exhibition space, some of you might be familiar with the Sibona facility in Johannesburg. The photograph that I put up is, in fact, from the Sibona in Johannesburg. It's pretty much what a science center does. It's interactive. The students get to engage with the components and test it and see how it works. So it's not just a museum piece, it's actually part of the education. And then we introduced multi-purpose classrooms and laboratories where you could in fact have remote teaching, so that from this center they could send out the lessons to all of the schools, high schools in the Eastern Cape in a broadcast method, and get science and mathematics and technology actually into those schools where they don't have teachers. And then clearly is the storage and evolution facilities. So I'm not going to deal with the architecture in this particular time slot because we simply don't have time. If Ryan wants to at a later stage, we can get into that because I think there's some interesting components there. So for now, I'm just going to restrict it to the science and technology component. So Coffin Barber is in the Eastern Cape. Take a line between East London and Queenstown. It's a little bit northeast of that line. Deep Eastern Cape, deep rural Eastern Cape. This is a Google map image that I've captured. That would be the road to Queenstown, and the village is located here. One of the poorest municipalities in the country. The last figures I saw, it had a total rates income of something like 44,000 Rand a year. So completely dependent on government grants, a very poor community. The municipality allocated a piece of land to us over here, right opposite a rather large high school, about 1,600 students. So that presented a wonderful opportunity at the same time. And so we identified some of the kind of objectives that we would like to see, apart from the programmatic requirements and apart from DST's objectives. What would we like to put in? Restoration of stormwater became a critical issue. The site was being eroded very severely. Municipality's own stormwater system going down here was completely eroded, so we reconstructed that. And what was important about that is that that is actually serving a wetland, which you can just see traces of at the bottom here. To the extent that these surface stormwater systems were not operating anymore, It was in fact creating real challenges for this wetland, not getting the nutrients in the water and the stuff that it needed in order to survive. At the same time, the whole of the Eastern Cape, it's not unique, Baba, is suffering a severe degradation and a loss actually of indigenous grasses. And so the opportunity presented itself here to actually do some grass restoration, get some indigenous grasses back, with the hope that the seed regeneration could in fact then take place and we could supply a bigger area. Sorry, I think, yeah, okay. So we looked at the site overall, how we could start engaging with restoring the ecosystem inherent in that site, and then looked at what we could do around the building. And so the first thing, obviously, that comes to mind is energy. Don't need to explain those challenges to you guys. And so we adopted a position here, could we power this building by nature? Obviously, the photovoltaics is a kind of a no-brainer. Originally, we looked at putting up some small-scale or building-scale wind turbines attached to the building. They're not smart. Wind flowing over the building causes too much disturbance around the edges, and so these poor things don't know what they're supposed to do, which way they're supposed to face. So ultimately, we abandoned that and put up a 10-meter high vertical turbine to generate wind energy. It's high enough to get above the eddies caused by the building. So we got the sun, we got the wind going, and then we introduced hydrogen fuel cell, which is operating, and that's quite neat. We collect rainwater off the roof of the building, specifically in a tank dedicated to supplying the fuel cell. And what the fuel cell does is it takes the water, which is H2O, splits off the two hydrogen atoms and releases the oxygen atom into the atmosphere, so you're oxygenating the air, and uses the two hydrogen atoms to drive the fuel cell. So all of that is coming from rainwater, which is being harvested for free. So we actually, apart from the installation costs, are largely running systems here, wind, sun, and hydrogen from collected rainwater, which are delivered by nature for free. Inside here, just a little aside, is a command center that monitors these three energy sources, and depending demand and depending conditions, so if the wind is strong enough, we can shut off the hydrogen fuel cell. If it's not, and there's an overcast day and we haven't got enough sun power, we can switch on the hydrogen fuel cell. If there's a massive event taking place at the center, you can use all of those. And we use the wind power at night to recharge the batteries for the solar, so that in the event that there's a bad day coming up weather-wise, we actually have fully charged batteries to run the center the following day. Look, the same, could we water this building by nature? So rainwater harvesting is a major. I've collected half of the rainwater from the building, and those go into 4,000-liter tanks, which I'll show you in photographs a bit later. And so all the urinals, all the basins, the toilets, all the water requirements for the building are in fact supplied by the rainwater tanks. The rest of the roof water is derivatively discharged onto the site to support the ecosystem. So that goes down to the wetland, it goes into the grasslands. So rather than harvesting all of the water, which in fact then stops the site from being able to absorb that volume of water, we're kind of sharing the resource between ourselves and what the site needs. We then installed an anaerobic biodegradable, a bio-based black water treatment system. So this operates completely off grid, and it's a closed loop. You start off with a tank of water, which flushes the toilet. The solid materials go into an anaerobic tank where it gets treated, goes through a number of filters, and that water is then pumped back into the tank for the next flush. So there's a minimal amount of loss, basically evaporative losses. So you need to top up the tank every now and then. It's not a lot, but you do need to top it up every now and then. We have the rainwater harvesting on site to do that. The energy to pump this water from the tanks back up into the water tank comes from the solar powers, so we're not actually using any fossil fuel to do that. And the dry material comes out almost like a powder, is compostable, and so you collect it and you can in fact use it as a compost. It's completely treated for any bacteria and virus, bugs and the rest of it. So that's an off-grid sanitation system. It's certified by Agromar and is perfectly legal within the country. We then looked at dealing with your water from your basins and your urinals, and for that we built a reed bed, where essentially the reeds harvest all the salts and minerals and organic material from the urine for harvesting purposes, and leaves you with a clear water. This particular example is not from the site, but this is a private swimming pool where they are using the reed bed to in fact filter the water. So all of the water on site remains on site. All of the waste that we're dealing with remains on site. It doesn't get kicked off to the municipality and now you solve the problem, municipality. Whatever is generated on the site, we're dealing with on the site. Same time, Richard Murphy did this British High Commission building in Sri Lanka. And what he did, Sri Lanka is a kind of a tropical environment. So maintaining a decent airflow is crucial to provide an indoor environmental quality which is acceptable. And essentially you create a hot zone up here, which allows you to pull cool air from a lower level through the spaces you want to chill and exhaust out at that up at the upper level. So we used that principle. I didn't use the glazing. I wanted higher temperatures than you would get with glass. So this is a 3D model, and I'll show you the pictures of it, as I said, in the end. But essentially, we've created two solar chimneys. They're clad with corrugated iron, so it gets incredibly hot. And so as the day progresses and these chimneys heat up, they begin to draw air from lower level ventilation that we provided in the classrooms. And that then gets drawn through the classroom up into the chimneys, and with the help of some twirly-whirly birds up at the top, we actually managed to exhaust that. So we get a ventilation system going simply by using solar power. Then a major component of the work was to go for non-conventional construction materials. And we used two systems here, a light steel frame, because we're dealing with quite big spaces, and an ICC, which is an insulated concrete composite. So the light steel frame follows, you may or may not be familiar with it, but it's basically structured in the same way that a timber frame building would be built. But instead of using heavy steel sections, you use light steel sections. You get massive weight savings, mass savings, obviously, and speed of erection and all the rest of it. So that dealt with the bigger spaces. The insulated concrete composite, on the other hand, is really using polystyrene. In the illustration here, it's a neopore material. It's basically a polystyrene with a graphite content. We landed up using plain polystyrene here because it really wasn't necessary to spend the extra money to get the insulation values that we needed. We could do it with this. But it's essentially sheets of polystyrene to which a mesh, galvanized steel mesh is attached on both sides. And then a very high performance cement coat is kind of gun-nited onto it. It's a bit like making a swimming pool. where you put up your steel frame and then you shoot concrete at it. So to start with, your insulation material acts as a formwork, as a shutter, if you like. As the concrete sets, the concrete then takes over the job of the structure, becoming the structural element. So you have two skins on both sides, and your insulation then just becomes the insulation material. So all of the single-story area of the site, the ablution facilities, and the classrooms and so on, were constructed using the system. When we started, I wanted to use a third technology, a modular system. And unfortunately, the company that we were designing with at the time ran into some difficulties. And so we couldn't use that, which is a pity, because I would have liked to have demonstrated the three different systems, but it just wasn't meant to be. So why would you want to do this? Well, ultimately, what we were looking for was to achieve the highest possible insulation values that we needed for that area in the Eastern Cape, which curiously enough is more cold than what it is hot. So just to give you some indication, if you look at insulation values, a double clay brick wall is 0.35. If you go to a cavity wall, that goes up to 0.6 because you get the value of the airspace in between. If you fill that airspace with insulation, you can take that up to 1.35. And that is there or thereabouts where SANS XA is being targeted. If you go to the light steel frame, however, you're jumping up to values of 2.8. And if you go to the ICC, you're going up to 3.7 plus. And the plus is just how thick you want to make your insulation. So the aim here was to keep whatever heat was being generated inside the building, and that heat is essentially body heat from the people present, is to keep all of that heat in the building so that we wouldn't land up with an expensive and energy requirement in terms of heating the facility. So that was the main aim. However, there were some additional spin-offs that we were aiming to target. The first is that the soil in this area is a very clay. Had we gone with conventional construction, we would have had to dig down something like 2 meters to remove all the clay and bring in fresh. We would have landed up with significant foundation challenges to stabilize the building. So going to the lightweight construction meant we could actually do a raft slab with some downturn beams, and we saved over R1 million just doing that in foundation costs. But at the same time, because we substantially reduced the cubic volume of concrete needed, and therefore the cement, we showed significant carbon dioxide savings from the concrete saving. So that was a benefit. And then a really interesting thing, I thought it was going to happen, so I wasn't surprised, but I was really encouraged seeing it. This was a random day. The contractor didn't know I was coming. He hadn't prepared the site because he knew I was coming. This is just a random construction day on the site, and you can see no demolition or material waste. The reason for that is we emailed our CAD drawings, and you guys would like this, emailed our CAD drawings to the fabricator. He converted those drawings into his CAM machine, computer-aided manufacturing machine, and each one of these components was cut and fabricated from the drawings. So there was zero waste. And you work out your, like a Meccano set, you work out your lengths from your standard length of sheeting so that you get the maximum number of cuts out of it with very little waste. The waste that they did have, they recycled and put back into the next steel mill run. So that was a completely closed system. These things were fabricated in Bloemfontein, where the factory was, and was transported by truck down to the site and erected using this simple little crane here with a couple of guys. So all of these pieces came pre-assembled, but like making an architectural model from cardboard, where you cut your wall and you glue it in place. I mean, that's essentially what happened here. And then, of course, this is polystyrene sheets that come in sheet lengths, and you cut on site and cover. So there's absolutely no waste around here. A significant saving in terms of materials, and those are resources. And all the resources and all the materials that we use in construction is made, extracted, developed, fabricated using fossil-based fuels. So just in doing this, already a significant carbon dioxide saving. So some pictures then of the end. So this is our solar chimney, the upper end of the chimney being in a ribbed corrugated iron. We were getting significant temperatures up here, something like 78 degrees C on the day, and pulling in the air down the bottom here, which then goes through the classroom, up into the solar chimney, and exhausted through the twillies up at the top. All the rainwater from that roof, half of that roof and this roof, is then collected in these rainwater tanks. They are connected to each other and then supply all the water needs in the building. This is a shot of inside the internal foyer. There's a significance around this, but I don't have sufficient time. If we have time at the end and someone wants to ask me that question, I can answer that. Foyer going into the exhibition space. More shots of the inside of the exhibition space. These are the labs, the classrooms, they're all connected to satellites, so we can in fact broadcast from here to the schools in the Eastern Cape. They are subdividable, so you can have 4 different classes going simultaneously, or connect 2 or connect 3 or connect 4, depending on how big your class is. So we tried to put in as much flexibility as we could into that facility. You can see the grills over here. So the air comes in across the window, goes in through the grills into a space that goes into a void that goes into the solar chimney. That's just a shot of the admin space upstairs and the view of the building from the end. So the nature-based solutions that we landed up employing at the end of the day was solar water heating, the photovoltaic cells, solar-powered chimneys, rainwater harvesting, the reed bed to deal with the urine and wastewater, the sanitation system. We've got water coming off the building, going through to the wetland, and we've got grassland restoration taking place in place. So all of these are essentially technologies that are delivering the kinds of infrastructure services that we need, putting no burden onto the municipality. There isn't a sewage load being put onto the municipality. There isn't an energy demand load being put onto the municipality or onto Eskom. The stormwater is not being discharged into a municipal stormwater system. It's in fact being dealt with as part of a broader ecosystem. And so the ability then to use these technologies in a way that frees up infrastructure from its typical greenhouse gas emission profile becomes evident. A nice shot. I didn't take it, so excuse the squiffness in the photograph. We've got the rainwater tank up here as a backup, so the water gets pumped here to give us some gravity feed. There's the wind turbine in the background, the solar systems, both for heating and for power generation, and the solar chimneys. And that's essentially the story. The building was opened earlier this year. So the Eastern Cape and the Department of Science and Technology are in the process of getting everyone on board in terms of staffing and so on, and developing the program for rollout. We will keep an eye on it, see how it performs over time, what the challenges are. I suspect a major one is going to be for the building operators, having to deal with technologies that are not familiar. So those are going to be the kind of teething issues that's part of essentially the learning process. One thing to roll out technologies, another thing to make sure that those technologies are operated at the kind of levels that they're supposed to be. But there it is. So if, I don't know if we have time, Ryan, but if there's 5 minutes or so and anyone has a question, I'm quite happy to additional 10,000 at the back, part of which is to support the hydrogen tank. Your comments, and I'm sure some of this was recognizable to you from the pictures of tricky. Reasons, mostly operational, actually, not technology. So we wanted to have another go at this one, making the process a little bit more simple, and standing at the same time of. So yeah, it is a new thing. It is experimental. We know it works, but actually, getting it to operate at this scale, and then the really interesting one, which was a major puzzle, was how to integrate it into the other energy sources, so that you have an integrated energy supply line. You know, you've got solar, you've got wind, you've got hydrogen. Which one do you use when, and how do they kick in, and how do you know when it must kick in? So the integration actually presented the biggest challenge out of all of it. Not the individual technologies, but how to integrate those technologies so they can actually begin working as an ecosystem on its own.
I think what you mentioned, if I recall, when we worked, or when you gave us the project to work on the net zero houses, that were an advancement of the 51/9 house that you'd mentioned to us. The integration of systems was relatively difficult to pull off. Now, I'd imagine the same thing occurs here. What's the process that you go on about to develop the integration of the systems? You first have to say work out the capacity of solar power that you'd have on the site, and then how that would somewhat connect to the water pumping, or what's the kind of process that you take? And I think particularly for students, it's a really important facet to take into consideration. It's an entire science on its own, but maybe you can just give a little bit of direction.
Yeah, so the whole system is automated. So there's a bank of computers in there that are actually administrating it. So you want to take out the guesswork from anybody deciding, well, I'm going to flip this on or switch that off. And so there's a program that was developed and written that would then facilitate the switch on, switch off, depending on a number of parameters. That would be what is the capacity of what is being generated at any moment in time by the solar panels or by the wind. How much energy do we need? Where do we need to get it from? And so that system looks after itself. So it's highly automated. It's one of the areas that I think artificial intelligence is going to be able to help us an enormous way down the line. So the algorithms that you need to run to develop to get the system to run seamlessly and almost instantaneously is going to require some technology development down the line. So this is a relatively simple building in the sense that its energy demands are fairly predictable. But when you get into more complex things, particularly like mixed-use buildings or residential buildings, where you get peaks and troughs, people come home, they switch on the stove and everyone goes to shower and bath and huge demand, and then it suddenly flattens off and everyone goes to sleep. When you start integrating it into those kinds of things, it could be a bit of a challenge. But you know what? There's a whole bunch of guys that worked on this, on the hydrogen installation. So if you wanted to, we could arrange a separate lecture for the students just on that. And I'm sure they would find it really interesting.
I think they would. And I think based on all the things you said now, that's why you're the right person to write the new qualification with us. Give us excellence in direction there. So, Mr. Van Wyk, thank you very much for that info. I don't know if there's any other questions, unless Ryan wants to take over. Oh, Masi.
Yeah, just a quick.
Okay, we have a few more questions from some of the lecturing staff. Thank you, Mr. Van Wyk.
Pleasure, man.
Hi, Mr. Van Wyk.
Hi.
Yes, my name is Masi. Let's have a quick question regarding the water filtration, right?
Yeah.
I know that you mentioned that you're utilizing wetlands, grass wetlands. However, I did miss where specifically that water would be servicing in the building after it had been filtered. And also a major question that I've always sort of had is there some sort of ratio, for example, of the area, like the flat area on the earth, to how much water can then be filtered? Like, for example, let's say 10 meters squared per 1 liter, something like that. Just a quick synopsis around that. I'd really much appreciate.
Yeah. So a colleague of mine, engineering colleague of mine at CSR, worked with me on that component. If you guys like, I can send you the actual report that he prepared, which really would be useful from a teaching perspective. So he did all the research on that, getting into the calculations of what cubic meters of reeds do you need to deal with how much liters of water. So I can share that with you guys with pleasure. But the size that we came up with was based on what is the anticipated wastewater volume that we think we're going to get from the basins and then from the urinals. Based on that, you calculate the area of reed bed and water storage. The water from the treated water or the filtered water then gets put back into the urinals. Now you'd have to treat it, but you don't want to put that water necessarily back into the basins. As I said, you could, but you'd have to treat it. So in this instance, it actually goes back into flushing the urinals again.
Okay. No, thank you very much. That's pretty much all from me.
All right, thank you very much, Mr. Van Wyk, for your time. I think that was
Pleasure.
quite a fantastic and informative lecture. We really appreciate your time and the effort you put into presenting this. Yeah, if there are any more questions from anybody in the audience, then we shall definitely be sure to also send it through to you. And then we can also, like you said, arrange another lecture with the students. I think that would be fantastic.
Yeah, cool.
Sorry.
My pleasure. Thanks for the invitation, and the best of luck for the rest of your conference.
Thank you very much, Mr. Van Wyk, and enjoy the evening on your side.
Thanks, man. Okay, everybody.
Bye-bye.
Bye.
Sometimes there's no one else who loves me like you used to. Sometimes we're not ourselves. There's no one I can turn to. And I know all the feelings that we shared out in the past. And I know your relationships are never meant to last. And I'll take some time, but I'll be alright. Moving on, moving on. I know time's hard to, but I've had enough. Moving on, moving on, moving on. Sometimes there's no one else who loves me like you used to. Sometimes we're not ourselves. There's no one I can turn to. And I'll take some time, but I'll be alright. Moving on, we're moving on. I know time's hard to, but I've had enough. Moving on, we're moving on, moving on.
Google has recently submitted an abstract, Mtata, transforming the fractured capital of the Transkei to Bantustan, which was accepted and presented in the conference proceedings of the Agora Kaum Conference 2020, which was hosted at the German University in Cairo, Egypt, on the 25th of November 2020. The same paper was accepted to be published in Space, International Journal on Space Studies and Architecture. I take great pleasure in welcoming Kaka, and I would like everyone to extend a warm welcome to here in person to the presentation.
Akil has already introduced me, and today what we'll be looking at is this workshop which talks about the architectural professional as an agent of reconstruction and development. And so I developed this workshop as a full-day workshop that I presented side-bit. However, for the purposes of this conference, we'll just be looking at two parts of the workshop, which is point number 1 and number 2. The first being democracy and the reconstruction and redevelopment program. And then number 2, the architectural professional as an agent of reconstruction and development. All right, and so under the first part of the presentation, which is looking at the democracy and the RDP, we'll be looking at 3 points. Number 1, what is the reconstruction and development program? Number 2, the need for such a program. And then lastly, we'll be looking at the 6 basic principles of the RDP. So, according to Katie Scott of CNN, she said in 2019 that South Africa is the world's most unequal country. And this was after 25 years of freedom. She said that we have failed to bridge the divide of inequality in South Africa. We're now 28 years into the democracy. And I think the statement is still very much valid. And Sipho Masombuka said in 2010, a third of RDP houses are substandard. Can you believe that? A third of RDP houses are substandard. And then Anne Bainstein, she said in 2019, the apartheid legacy of urban sprawl is still a challenge in our cities. And so it's quite an interesting one to find that after 28 years of democracy, we're still sitting with the same type of urban development in South Africa that should have at least been addressed to some extent at this point. So the question that I pose to kick off this part of the presentation is, has the RDP failed? And that's a question that I think we as professionals really need to take time to think about. And that requires us to then ask, what is the RDP? And if it has failed, why is it that it has failed? All right. So the definition of the RDP is that it's an integrated, coherent socio-economic policy framework. And what it sought to do was to try and mobilize all of South Africa's people and the resources of the country toward the final eradication of apartheid and try to build a new society, a new democratic society that was non-racial and non-sexist. So that was the overarching goal of the RDP. And in so doing, this led to the question, why do we need a reconstruction and development program? And this is outlined very clearly in the RDP. And we have to think about this from a point of view that this was in 1994. And at this point, we were transitioning from the old regime into the new regime. And they were looking at what can we do to deal with the ills that were caused by the previous apartheid system. And so why do we need the RDP? Number one, to deal with the legacies of colonialism, apartheid, which have resulted in poverty in most of South Africa's rural places, and have also resulted in degradation of one group. But then you get one group living in luxury and wealth. And that's basically shown in that picture that we had a look at earlier, where you have a clear divide of, on one side, you have a degraded area where you have shacks, and on the other side, you have a suburban area which has quality spaces that are fit for purpose and for the quality living of people. So the next part, or the next point that the RDP wanted to deal with was an economy that was built systematically on enforced racial division. And this, as I said, resulted in underdeveloped rural areas known as Bantustans in that time. And we then get this juxtaposition, of if you go to most towns in South Africa, what you start to find is that there's quite a developed city center with suburbs in some cases. And then adjacent to that, there's undeveloped rural areas. There's townships that are also quite underdeveloped. And these are marching along side by side at different paces of development, and some not even developing when compared to their counterparts. And so the third point that the RDP identified was that they needed to deal with segregation. Now that's in education, health, etc. And in dealing with that, they needed to eradicate inequality, as we said, and economic inefficiency. And now, if you think about economic inefficiency, it's very clear to see in South Africa, the pockets where money is coming from and where money is going. And why it's clear to see, it's because if you go to I don't know Cape Town that well to tell you the areas, but if you went to my town in Umtata, you'll see various areas where there's RDPs and very, very low quality spatial design and very, very low quality spaces for people to live. But then if you go to some of the suburbs, you'll find that it's very nice spaces that people can enjoy. There's parks, there's nice neighborhood centers, etc. And so the inefficiency of that type of planning is very clear even today. And so another question that the RDP had to ask, which was an important question, was how do we then implement this program successfully? And so in conceptualizing that, what the government at the time said was that, well, we need a program that is achievable. And we need a program that is sustainable in the long term. And we need a program that will meet the objectives of freedom and will improve the standard of living and the quality of life for all South Africans. And so I think if you think about these requirements, it's not requirements that are complex and difficult to understand and articulate. But I think the difficult part when about these concepts is the actual implementation. And so that being said, the RDP provides a framework for the government to be able to make decisions that will achieve sustainability and meet the objectives of improving the standard of living and the quality of life for people. And so, in summary, that's what the RDP is. It's a decision document for the government to be able to say, look, because we have set out this vision for South Africa, when we make decisions, these are the priorities that we need to be always cognizant according to our overarching aim. And so all reconstruction and all development should be aligned to the RDP. Okay, so the RDP also lays out principles for development and construction. And the first one is an integrated and sustainable program. And so what this basically speaks to is strategies that harness state resources in a coherent and purposeful way. And then number two, these strategies should be implemented at a national, provincial, and local level. And so basically what we're saying here, whatever is done at a national level in South Africa should be filtered right down to the local level. And so whatever development is being planned should be in alignment with the national objectives. So whatever municipalities are doing, they should be trying to meet the national objectives. And so if you've read the National Development Plan, which we'll come to later, you'll start to see that the people who wrote this document were not stupid people. They knew exactly what they were talking about, and they had really thought out the problems in South Africa, and they had a plan that could work, I think, if implemented properly. And so these principles, they make up the political economic philosophy that underlies the RDP. So number one, integration. I think we've heard that a lot. I mean, even your courses talk about integration. And I think where that integration actually comes from is the spatial segregation that we have in South Africa requires integration of the whole. And there's a friend of mine who really likes to say that the whole is greater than the sum of its parts. And so in order for South Africa to work properly, the whole needs to function symbiotically. And we mustn't have pockets where some people are doing their own thing and others are doing their own thing, especially in government. You'll start to realize this when you start to deal with municipalities. You submit a plan to the municipality, and then they tell you, when you are following up with regards to approvals, that it's still with another department and it's not their fault. That department hasn't addressed a particular issue. And you think to yourself that the government should be integrated enough to be able to deal with its inner functions. You as the person who's the architect submitting plans shouldn't have to be trying to coordinate and integrate the functioning of the municipalities inside their own departments in order to get an approval for a plan. And that's a challenge that we're facing in a lot of the municipalities. I do work in the Eastern Cape and I do a bit of work in the KZN. And I think the one place I've faced this challenge a lot is in the KZN, where the municipality seems to be struggling with communicating within its departments. And so we've also been, as CYBID, involved in that, trying to assist, the industry. We've got a voluntary association collaboration, which is made up of CYBID, SIAT, FACE, and other voluntary associations. And we've been in negotiation with the municipalities, trying to assist in resolving this issue. So that's integration. Number two is a people-driven process. Services to communities has been approached in the past. But now you start to get out of this philosophy in the RDP that people should be part of the process, people should participate, there should be an engagement at grassroots level, and there should be a bottom-up approach. And so you start to hear such ideas. And that's very important, because when you start to create places for people, you don't come most times to a blank canvas. Even though we as architectural professionals, when we start to design, have a sort of a blank canvas. But in actual reality, you don't always get a blank canvas. There are people who are there already continuing with their lives. And so whatever intervention that we make has to be in alignment with supporting those people with with assisting them to take what they have and build it and improve it incrementally. And so, as the RDP rightly says, development is not about the delivery of goods to a passive citizenry. But what do we have in South Africa now? We have a passive citizenry who just receives grants and solutions from the government. Whereas the plan was that people should be active, they should be involved, and they should be empowered. And so I think we as architects need to start thinking in that sense, if we are not already doing that, that when we are designing, when we are providing solutions, we are empowering that community. And I really like the presentation that was before mine. That's a very, very, I think, good response to the design problem that they had in Gofimvaba. And so participation is key, as the RDP rightly puts. Sorry, I seem to have a... There we go. Thanks, Hakim. Okay. All right, and so the third principle that the RDP deals with is peace and security for all people. And it's interesting that you would deal with this in, or let me say, I don't think many times we as professionals think of our design solutions as providing peace and security. And one of the things we get taught in design is that when we design buildings, you need to have, your buildings should be designed in such a way that you can have passive surveillance, you know. You shouldn't have to put your buildings behind tall walls with barbed wire and electric fences. I'm not saying that is wrong, but I'm saying if we design in a way that our buildings could have spaces that are visible to everyone who is using that building, then we wouldn't need as much security devices that we are implementing in most cases. And part of the problem that exacerbates that is that obviously you're gonna need a high wall and an electric fence if your neighbor, you know, on the other side is coveting what you have and they don't have it. So the RDP says they wanted to promote peace and security. They wanted to establish security forces that reflect the national and gender character. And they wanted a non-partisan professional and to uphold the Constitution and respect human rights. And so I think that sort of talks to basically, we all know in the old government, everything was, all useful sectors of government were predominantly white. And so basically what this talks to is now integrating Africans and other races into that framework. The fourth aspect is nation building. And the RDP says that we must not perpetuate the separation of our society into unequal spaces. And what do we have now? Are we still perpetuating segregation in our communities? That's the question. Number two, it says that we must not confine growth strategies to the former, which is the first world type setup, while doing patchwork in the third world types patch up. So usually, basically what this says is that the areas that are already developed and have investment and money tend to attract more investment and money. And so they tend to develop. But the areas like the townships, which haven't had investment and money invested in them, they continue to lack in investment, because obviously what the perception is that in a township, if you do certain things, they're going to be vandalized, or they're not going to be cared for, or whatever the case may be. And the RDP says if we're going to build a nation, we need to build an equal nation for everyone. And if you think about it, and I've been thinking about this for a little while, imagine if the apartheid government had done for everyone what it only did for a minority. In my estimation, I think South Africa would be like America now if the government had had that vision to say, look, let's not be afraid of competition from the majority. Let's empower everyone to have an equal chance so that we can build a great nation that has opportunity for everyone. And you can see clearly in America that when you allow different types of people, nationalities, and skills, in fact, when you bring together different types of people and nationalities, what you start to see is a wide range of skills and collaboration that usually comes with even more useful things, you know. And so, that being said, I think if the previous government had had that foresight to say, let's develop the whole country so that it's able to take care of everyone, today we'd be sitting in a very, very different situation. And I think we would be right up there with the other first world countries. Unfortunately, that didn't happen, but the RDP gives us the framework on how to get there. And so it's only a program that develops economic, political, and social viability that can ensure the growth and the sovereignty of a nation. Currently, we are very much stuck in the political space, and whereas we should be trying to make sure that everybody is on par economically, politically, and socially, you know. And so those are, I think, are very good things to think about as architectural professionals as we go about our everyday work. And sometimes it's very difficult to think about that when you're just doing let's say, a house. But if we start to contextualize our thinking, I think we might find that even the humblest of tasks can have a greater value in the long term if we have really, really applied ourselves to what we want to achieve. So another basic principle that the RDP refers to is the linking of reconstruction and development. And basically what this says is that every time we think about development, it should be conceptualized in a manner that how can we use this development to address the ills of the past? And so many times I think government thinks that they're just providing a whole, but in actual sense, any sort of building or design solution that you're providing should be a viable economic solution, you know. So you're not just providing a building, but you are reconstructing parts of South Africa that have not been developed properly in the past. And that's why you see now that there's a drive. In fact, there has been a drive for a while of building schools, building community halls, clinics, etc. But I think the part where we really sort of lack is linking those developments to addressing the ills of the past. And so in many instances, you find that there's very nice buildings that are being built in South Africa, but they end up being white elephants, you know, not being used properly and degrading and becoming fruitless expenditure, because when being conceptualized, the people weren't really thinking of how is this development going to meet the needs of the people? And is it going to be sustainable long term? And is it going to improve the lives of these people so that they can be able to start generating productive activities and money? And so I think for me, that's a very, very important aspect to always be thinking about. And so the other point that the RDP covers is the democratization of South Africa. And obviously this entailed a change in policies in South Africa and a change in programs, because now a new system needed to be managed. And so that means that you need to have new legislation, new laws for that. And part of this change in policy was to allow for the previously disadvantaged people to participate in decision making and in the development of the country. And this is not just for the previously disadvantaged people, but this is for everyone in South Africa. We all need to participate in decision making in South Africa. And how we do that is by reading documents such as the RDP, so that even when you are still conceptualizing your design, you can ask yourself, how is this design addressing part of the problems outlined in the RDP? And so I think that's something very, very crucial to keep in mind, because essentially through our work, what we're trying to do is to transform the state and society to some extent. And this will become maybe a little bit more clear as I get into the second part, which deals directly with the professional. But here's something else that's important to note, is that what the RDP is mainly sought to achieve, or part of the things that it wanted to achieve, was enablement. And enablement is a concept that says we don't want to just provide solutions with people, but as I said previously, we want to empower them, we want to enable them, we want to support them so that they can be self-sufficient. We all know the saying that you give a man a fish, you feed them for one day, but you teach them how to fish, you feed them for an entire generation. And that's the sort of thinking that we need to sort of have, even as we are doing the hum list of tasks. And by doing that, we can start to really contribute to the reconstruction and development of South Africa. And so the 6 basic principles of the RDP, when put into a single phrase, is that it's an integrated program that is based on the people. It provides peace and security for all and builds the nation while linking reconstruction and development and deepening democracy. Now the question is that what's happening in South Africa? Can I pose that question to you guys in terms of, is development in South Africa really based on people? Number one. And is it providing peace and security? Think about the recent unrest we had in KZN. Why are people restless? Why are people now engaging in those type of acts of instability and unrest? You know, and is the government actually building the nation? And when we talk about building the nation, we are building the nation so that it can function as an integrated whole and not have certain pockets functioning better than others, you know. And so anyone want to give their 2 cents on that, what your thoughts are in terms of sure.
Thank you, Mr. President. I think there was very insightful words and extremely valuable information. Just for those who are online, I'll take some questions from online now. I just would like to direct some questions at the SRC first. The SRC was invited to listen to this particular session because they are now the first cohort of SRC members that CAD4ALL has formally instituted. We've had a small run last year, and this year has been a formalized process. And we are trying to build a community within the CAD4ALL Institute, a community that's going to be driving the future of this campus and moving it into a direction that we think is technocentric, that is progressive, inclusive, participatory. And so what we are going to be, or the way I'd like to pose the question to the SRC students, is that you see a really useful tool that's being communicated in what Mr. Mkaka has mentioned. He's mentioned that the policy provides the work for exceptional decision-making. That's a really important tool. The SRC had to write a constitution this year. The constitution needed to provide the foundation and the benchmark along which decisions need to be made. Now, in terms of a student context, the way I want you to think about it is, when there is, say, perhaps some sort of uprising, if you could call it that, some sort of uproar, some sort of disagreement, how should students go on about expressing their issues in a way that's not detrimental to the campus, in a way that doesn't allow there to be slurs placed amongst people? Or if you don't agree with something as part of your curriculum, how can the policy that you guys write facilitate a better interaction between the academic team? There's also things like, maybe you just want a vending machine on campus. You and Bay want to do something exciting with the vending machine. What do you do? How do you go on about that? And there's ways and procedures. It's about effective decision-making that allows inclusivity of people, even those who might be seen as marginalized for whatever reason that is. So the SRC, I'd like you to ask a few or pose a few questions to get out of Mr. Mkaka's reflections on the RDP policy. How can we have a similar, very cohesive guideline towards making our decisions? Amber, perhaps you might want to go for it.
Yeah, I actually had a question about developing, say, communities.
Sure. Do you want to come to the mic?
Oh, okay. Okay, you can hear me, right? Okay, cool. So my main question was, when developing a community, say, that was almost half forgotten about, where schools are being destroyed, where learners don't feel that they have the necessary, how can I say, commitment to be at school because they're just going to end up where they see other peers are in the community. So for the municipality to step in, how can we, almost like how we start designing things, how can we include other businesses, like say a wind farming business, to come into the town and help us build this community, but also sending out students, say, or parents of these students, to give them an opportunity to build the community, but to come back after studying or learning from the wind farms itself and bringing it back to their community to actually push back into the community and building a future for their children also. So I think the main thing is for education purposes, but also working hand in hand with municipalities before including a democracy of the political parties in the town itself. How do we go at that before we include the hierarchies of saying we can see where they have not included the communities itself? How do we go at that?
Okay. Let me see if I'm hearing your question properly. So what you're asking is, how do we involve communities in the design process? Is that what you're asking?
Mainly, and how do we help them develop their own?
Or develop their own, or what they have. Okay, so, all right. So thank you for that. That's a very, very good question. And firstly, you'll find that when you work on a project, there's a pre-design phase. And I think most times that is very neglected, because during that phase, that's when you start to do your research and interacting with communities and finding out, which is the participative process that I was talking about, or the bottom-up approach. You go into the communities, you spend time with them, you find out what are they doing to help themselves. And I think many times we sort of look down on what people are doing for themselves, and we come with these utopian visions where we say, actually, this is what you need, and many times that's not what people need. People just want to go about their work and make their money and provide for their children and their communities. And so it's very, very crucial to understand what are people already doing for themselves. And so in doing that, you can then start to appreciate that whatever intervention that you're going to do there needs to start from where the people are. And then you need to then support them, because now you're the architectural professional, you're the professional, you have the ideas, you have the expertise to be able to develop the ideas to work better for them. So that would be then the starting point, understanding your client properly and then building with them. One architect calls this, this is generally known as sometimes incremental development, which I'm a very big fan of, that you even as an architectural professional, when you start to come up with a design solution, most times, or maybe what you need to understand is that your solution is not necessarily the final solution, but it could be a starting point for people to build. And so by involving the people, you then give them a sort of ownership of that project. And even when you've done the design, they can continue to improve on the spaces however they like. There's what I look at in my thesis is what they call, the words escape me now, but basically what you do is you lay out a framework, for people to be able to continue to build within what you've already designed. You understand? Because what you find that even though we've given people spaces, the change of use or the use of the spaces sometimes changes. And so whatever spaces we design need to be adaptable to the needs of the people at the time when they need to do whatever they need to do. Because it's not necessarily a one size fits all. And I think that's the main part. If we can get the participation right, then it will start to inform then if this is the problem of the people, who do we then need to engage in terms of businesses and other stakeholders for us to be able to meet this need of our client. I don't know if I've answered you in what I'm saying. And so, is there any other question?
I was actually,
Yeah.
I don't need to come up with it, it's just
Okay.
speaking on, I don't necessarily know I don't follow the news much, so I don't know what happened in KZN. But regarding the RDP program, I just want to get an understanding, is it that we're trying to implement this program, get more people on board with this program, or is there a certain group already that is trying to better the standard of living for people? Because you also mentioned 6 points, and I assume those 6 points are what they are trying to make better for the people.
Yeah.
To improve the standard of living. So is there certain groups that are on each point, that focus on each point, or do they tackle the task together and try to improve the standard?
Okay, so thank you for that. Firstly, the RDP was a program that was supposed to be sort of a plan on how to fix South Africa. And so the government was supposed to be the one implementing the program together with various other stakeholders, which we are part of those stakeholders as professionals, and also other organizations, private sector organizations, non-profit organizations. So it's a program for the whole country, for the nation. But the driver of it should be government working together with professionals. And when we get into the second part of the presentation tomorrow, you'll start to sort of appreciate that better, because that part looks at the part of the professional in the rebuilding of the country. And so what government did is they set up the framework so that the professionals could be able, when doing their work and implementing their designs, be aligned to what needs to be done in South Africa. And so the point that I'm trying to make here is that there are good ideas in South Africa. The RDP itself is a good document and it has good ideas. But the problem is that I don't think it has been implemented properly. It has basically been poorly implemented. So what I'm saying is, most times we think that we need to make a drastic change and come with very, very new ideas, but there are existing ideas that work and could work that have not been fully implemented. I think as it stands, South Africa has some very good policy on various things and various sectors in government in the country, that if they were implemented correctly and passionately and meaningfully, that we would see the type of change that the RDP was talking about. But it's just that there's been insufficient integration, government and various other stakeholders, especially the people they are working for. They are not really working with the people. And so I think that's mainly what I'm trying to get at, is that take this document, extract the ideas, and see how you can now start bringing that into your work in terms of meeting the needs that you see in Cape Town. Because this document wasn't just written by government, it was written by professionals who really know their story. And so I think it's quite a shame that it hasn't been given, its full accolades in terms of implementation. All right. So just to end off, I've already concluded. Tomorrow, we'll be looking at the second part, which now deals directly with us as professionals, which is the architectural professional as the agent. And we'll be just going through the policy document of 1999, which gives us some guidelines. And what we'll also look at is why did the regulation of the built environment profession have to be revised, in 1999, and why do we now have the different categories of registration within architecture, and what is it the government was trying to achieve by bringing that in. So thank you very much. We'll see you tomorrow.
All right, thank you very much, President. If you do have any more questions for the President, you will find him at his exhibition stall outside in the hall. Up next, we have the NHBRC, the representative there, Ms. van der Berg. She will be speaking to you guys. And the presentation is going to be highlighting the mandate and the role and the mandate of the NHBRC in the built industry. So if you just give us a few seconds, we're just going to switch over to the next presentation. All right, thank you guys for you joining us here in person and for everybody joining us online. Next up, we have Miss Agnes van den Berg. So she is in charge of the marketing of the NHBRC in the Western Cape. So that's the National Home Builders Registration Council. Just to give you a little bit of background for Ms. van den Berg, she's currently responsible for marketing the mandate and the role of the NHBRC in the Western Cape. Prior, she was the head of communications at the Western Cape Department of Economic Development and Tourism and the Western Cape Department of Health. And she also started out as an administrative officer at the Department of Labor. And very interesting to know and very keen for you guys, she has a very keen interest in strategic planning and forecasting of the future. So over to you.
Thank you, Ryan. It's good to be here. I want to share with you the information that Ryan has given you a brief on, but I also need to compliment you guys at CAD4ALL. In practice, I had contact with you only since yesterday, but I have to mention that I've seen you being so structured as well as disciplined, and at the same time that the respect that you show for one another as well as for the staff working here. And it makes it a privilege and a very pleasant experience to be with you. The NHBRC is what I really need to talk about, is what they told me to talk about. I could have continued talking about you guys. At the same time, I just need to mention that, and I feel obliged to do that about myself, is that I am trained as a futurist. In other words, the future is very much important to me. It's not just the past or the present. Unfortunately, the keynote speaker, in my view, yesterday mentioned that today is important. Yes, it is, but today is going to be very brief. The future is the one that we should be looking forward to, and that is why it's a privilege for me to share my information and my knowledge with you to take forward so that in your own futures, you might be applying the content and go forward in terms of your own careers and your own businesses. So the NHBRC's mandate and role and how it links up with the CAD4ALL is the fact that, in a sense, the NHBRC is like the cousin of the architect. The NHBRC is there because we actually have a mandate to, I'm already there. A mandate to regulate the home building industry and to ensure that a quality housing stock is built in the country. We protect the housing consumer. We're not there for the builder. We're not a builders club. There's a perception that we are, but we're not. And for that, I encourage you, if you haven't been collecting some of the material in front at the exhibition desk, that you do so to be able to understand what is the relationship between the housing consumer as well as the NHBRC and the home builder. We are like in the middle, in the triangle. A relationship between the NHBRC is in the middle between the homeowner and the home builder. Now, the very part to become a member of the NHBRC, it is important that the registration of the home builder takes place online. I'm sure you guys, I know you guys are very much familiar with electronic communication, whether in using the internet and going on websites, it's not news to you. But sometimes for the home builder, it is still news. And that is why I'm sharing that information with you, that in fact, there is a specific platform that you need to go onto. If it's an email information that you've been receiving, then you go to the NHBRC website. You would be able to click on the link and you would be able to open up the registration facility for the home builders. So you get started by building your unique profile, and then you submit your renewal or registration application from the convenience of your own home or office. Should you not have access, but in your case, it's not the case, you all have access, there's a possibility that you can come to the office at the Western Cape office in Century City or the one in George to be assisted. But that doesn't apply to you. You all have that access to the electronics. So this new digital channel is at the moment is right now, it's the only way of registering as a home builder with the NHBRC. And it is important that you renew your membership in the same fashion and that you apply all the other channels that has been up till March that you could have used is not available anymore. If there are any questions that you might have, or if unfortunately you get stuck somewhere along this specific electronic path, then there is a specific email that you can use. But all of this information is available on the NHBRC website. That is www.nhbrc.org.za. Now, what is important that we have not changed our requirements. Then the list of the requirements you would also be able to find on the exhibition desk. The list of requirements simply means this list that you could be seeing here is certified ID copies of each managing director of your company. Why is that important? That you need to realize that you can register as a sole trader, but that you can only register a company per se. You cannot come there and you are registering as Mr. ABC or Mrs. AZ. It is about a company that's been registered with the NHBRC or a business entity. Then what is important would be banking details. Why is that important? Because in the whole scheme of seeing whether a home builder should become a member, there are three things that we are looking at. Number one, there must be administrative skills, there must be building skills, and there must be financial skills within the company because the builder will be dealing and working with other people's money. Then this is the type of businesses that we register. We register a sole trader, a closed corporation, or Pty Limited that we've mentioned. For new companies, like yours, you would also be registering the new company. So you would be expected to submit the information as it is in terms of the notice of incorporation, your registration certificate, and your memorandum of incorporation. I just wish you luck getting that process behind you when you have to register your company, because that has to be done first. Then we also, if there's a trust, we will be registering a trust, as well as the partnership. If person is someone from overseas and they would like to work in South Africa or as a builder, then we need a 50,000 Rand bank guarantee. That's simply because we do not want the person to abscond with the money for someone that he's building the home for. We need some security. And then we need an indication of the years of trading. That's simply also to give us an idea about the experience within that company. In other words, whether they are building skills. There must be the details of the engineer who's going to look at obviously matters like the soil and giving some information or support in terms of the information with regards to the soil. There must be a proof of residence not older than 3 years of each of the managing directors or the shareholders or the owner. In other words, that is simply to secure that we're not talking fly-by-night organizations. What is important is sometimes a company does not have the person with the technical skills in the owner or the director. That skills can be coming from somewhere or is somewhere in the company, but it's not with the director or the owner of the company. What is then required is that we want a letter on a letterhead from the company to be submitted as support as part of the requirements to indicate that a certain person with some technical skills will be doing the technical assessment. The technical assessment is what has been called in practice as a test. home builders need to do a test with us, and many a time the information about that is required so that we obviously all the time the information is required so that we can let somebody else besides the owner write the test. It is important, like I said, that we want to have confirmation about the ability to deal with finances. And in a case where sometimes the person or a company has been receiving, being blacklisted, we need some information about that to be able to assess the application. The fees. There is an idea that the fees of the NHBRC is too high, but that is reality. What you see on the screen is in fact the reality to be the fee to be paid when it comes to your application itself. That's an administrative fee. Then there's the annual membership, because your annual membership must be renewed every year. And then there's the 87 Rand that should be paid for the home builder's manual. So the total application will cost the new builder to register for the first time 1,271 Rand and 93 cents. Why is it such a nice, unusual amount? That's because the NHBRC doesn't pay VAT. We are not a private company, so we don't pay VAT. So our fees have been, a couple of years ago, the fees did include the VAT, but then the 14% or 15% VAT was deducted, and it came down to these funny amounts. But that's literally the amounts that we ask for new registrations. Then there's this whole thing about enrollment. By the time a home builder is registered with the NHBRC, it doesn't mean it's the end of the road, because now the builder is registered and everything is honky-dory and everybody is happy because this builder is registered. What needs to follow is when the builder gets projects, those projects must be enrolled. One of our exhibitors outside has been explaining that they actually do a lot of that admin side of things, because a builder has a tendency to want to pull the brick to do the bricklaying and do the roofing and do the foundations, but they don't want to do the admin. Or they don't have people working for them that can do the admin. So that is, the enrollment is important. It must be done 15 days. That's a process that is also done with forms at the moment, because we're not doing that electronically yet. The home enrollment allows the NHBRC to do the quality inspections at various stages of construction and provides the housing consumer with a warranty cover for the minor defects, the roof leaks, and the major structural defects. Ultimately, the existence is about standards. We need to know that the builder should be building according to standards. And when the inspectors is to inspect the site, they will be comparing what they see in reality with the standards as we see that. There's an example of the publications. Now, there are key structural stages to inspect the home, and that's basically the foundation, the walls and the roof, and the overall structure that's being built. The inspector doesn't go out there to be a policeman. He goes out there to give guidance to the home builder and also to discuss what kind of challenges the home builder should be experiencing. What we are talking about there is when they have identified, the inspectors have identified technically challenges, they will definitely be having a discussion with the home builder, and then they will try to comply and bring it in line with what is expected from the standards. This is where, in a sense, the link is with the architect as well, because you're bearing in mind that somewhere a few months before, the architect has been drawing a certain design. The home builder should engage directly with the inspector who has issues when there could be some problems with regards to the gaps between the standards and the reality of the work. Now, What we need to know is then this warranty, and I've been giving you some information about the warranty at the desk, is that there is a 3 months maintenance, there is a 1 year roof leak, and there's 5 years structural warranty. So what you get there is basically in the first 9 months, the first 90 days, 3 months, after a new owner has moved into a new house, he or she must list all the minor matters that could have been wrong in that specific home. And then he needs to discuss it with the home builder. There's also a 1 year roof leak, especially in the Western Cape. We have it that after the first winter, after a person has moved in, you could be getting some leaks. So it is important that that's reported to either the home builder or directly to the NHBRC. And then the most important reason why the NHBRC exists is about the structural defects. Structural defects are important in the sense that without having sorted out the structural defects, the family living in that home could be in danger. It's basically the roof could fall on top of them, or there could be other structural defects that means in practice that it's not safe to live in that home any longer. That means it needs to be reported to the NHBRC directly, to one of the 2 offices that you've seen or the information on the website, so that it can be assessed and can be remedied. A couple of years ago, maybe you guys were too young. A couple of years ago, there was a big major problem here at the Tiger Falls, just across the building from Tiger Valley, the shopping mall. What basically happened there, it was a multi-story building, and unfortunately the foundation was done with little cubics that after a bit, well, not too long after the building was actually occupied, was in fact those little cubicles started rolling. In other words, at the angle, it's a quarry. So it simply means that at the quarry, standing at a specific angle, those little cubicles started rolling. And you got major structural defects in that specific building. I will show you quickly. That was the building after we started taking it apart. Because bottom line is it was not safe to occupy. I stood in one of the kitchens whereby the person was actually standing at the basin, and where the cracks started happening while she was at the basin, while she was doing her dishes. So it was really, really scary. We're talking about 8 years ago. Now, what happened was that we, in fact, did do what was required to be able to remedy the fact that there had to be conciliation between the owners and had to be discussion with the home builders and the engineer. At the end of the day, the NHBRC provided a sum of money for the builders to start going back to basics and for the foundation to be sorted. Unfortunately, in the process, you can imagine everybody lost some money. Because that is an extreme example, but it's an example that's right here on our doorstep. It's just across the road. And that is reality whereby the NHBRC had to step in terms of the conciliation process as well as the remedy process. Now, the one thing that some of the builders are very glad about is the fact that they automatically qualify if they registered with us. A home builder will, and his staff will qualify to get some training. And that we do simply in terms of improving the quality of the building. It's not about us being so good about this training. It's about we want the level of skills to be improved, and therefore we provide the training for the staff. Conclusion is that was important to realize that the NHBRC is not in this business by ourselves. We have to have partners. You guys are one of the partners. we have training partners, we have government departments, and yes, then we have a database of approximately 1,000 registered home builders in the Western Cape as part of our partnership. Every person that wants to build a new house, every person that is to get a new house via the government system is entitled as their right to live in a safe home, and therefore all of these parties have to come together to be able to create that. Oops, this is a bit funny. But the fact of the matter is you need to know where to contact us. If you can't read that properly, you can go to our website. We've said that, www.nhbrc.org. We're an organization, org.za. Thank you very much.
All right, thank you very much, Agnes. Is there any questions? Anybody got any questions? Devalt.
Yes. When it comes to structural defects in a structure, normally it would happen because of a communication error between architect and engineer, or engineer and builder. But is there maybe times that the builder itself would maybe skimp on materials to push let's say a wall to its bare minimum while still having structural integrity? But then after maybe 6 or 7 years, the wall starts cracking. But then obviously that wall has lasted its 5 years, but then doesn't last its maybe 10 or 15 years like it's supposed to. How does the RBC combat that?
Okay, I'm going to answer the questions as I receive them. In the case, unfortunately, because the warranty is valid for a period of 5 years, beyond that, the homeowner will have to take alternative measures to be able to resolve that. If it is like 5 years and a day, even, unfortunately, because that means that he would have to approach the other parties in terms of the possibility of the reason why that structural defect has occurred. Be it also taking up on his insurance, his straightforward insurance that he would have taken out because of being a homeowner.
Any other questions?
Yes.
So I just want to know, so these are buildings that are being built as it goes on with the contract and everything. But say it's a building that has been built already. So like a building that's been done, say, 2 years ago, and you see the structural defects, like say this year when they found out about the NHBRC, or say that they knew about it but they didn't take the integrity to actually go out and inform you guys about it. But then to skimp on money, can people say, if a new owner of the house comes and they take over, say, about the integrity of the home and coming to you guys to see what structural defects there are, and how does one go at that?
Okay, now the first question that we would have to answer from the scenario that you've sketched is whether the house was enrolled with the NHBRC in the first instance. In other words, the process that we've been going through in terms of enrollment, whether the inspectors have been able to inspect the building, the work while it's been done. If it's been enrolled with the NHBRC and it's within the 5-year period, then the NHBRC's inspectors or our engineer will go back to assess, and depending on what has been determined in terms of the integrity, the necessary measures will be taken. That's one set. That's your ideal set of facts. If unfortunately the house was not enrolled because the owner in some instances want to save some money and therefore they don't enroll with it, with the NHBRC, it means that in some cases then we were dealing with a builder that he's been building a home and not enrolling it, then the builder could be in trouble because we can actually call him for a disciplinary hearing because when he's been registering with us and being a member, a paid up member of the NHBRC, it means that he's confirming that he would take specific steps that is expected. Beyond that, it also simply means that there's an act, the act that actually allows the NHBRC to operate, that stipulates that everybody who is in the business of building new homes must be registered with the NHBRC, which means then at the same time they must be enrolling their own projects. There isn't much that we can do if a builder, for instance, is not even registered with us because it's outside our jurisdiction. If the homeowner has decided not to enroll despite just using this registered home builder, then the cost of that specific defect is not going to be part of the remedy the NHBRC can provide, because the NHBRC wasn't part of that. That in other words, the process of building the home. So it means in the end that the owner will have to bear the cost for whatever defect it is from his own pocket. Yes.
I have one question. When it comes to the NHRBC, is there maybe a minimum amount of homes that a builder must build within a year to stay in the NHRBC, or is there no limit to how many homes you can build, or is there a minimum to stay relevant within the NHRBC?
Okay. To answer that, when we're talking about an application for registration,
Okay.
there is an indication that we will be looking at all those factors that had to be submitted as part of requirements. Now, when the certificate is issued, the amount of units that specific home builder can build will be determined by what has been the history that's been given, plus the information that has been submitted as proof. That is sometimes a builder, especially the first time registration, would be getting the certificate telling him he can do one home. It's written right at the bottom, just before all the logos, how many homes they can build. Now, we have a system that you can actually increase that amount. First, I have to answer by saying we don't limit the amount of homes that can be built in a year, but we do limit the amount of homes that the builder can build with that certificate, which happens to be valid for a year. His membership needs to be renewed every year. So we are not saying you must build 10 homes in the year 2020, 2023. We're not going to say that. But what we would be saying on the certificate is the amount of homes we understand that home builder will be able to build and take responsibility for.
With that specific certificate.
With that specific certificate. Then what happens is, now in practice, it means that I'm now going out there and I'm going to start building on different sites. The inspector should be coming. You get your relationship going with that specific inspector. And then in practice, that's part of it, is that we also have on record what's been going on with regards to the enrollment for that specific builder. So the builder can apply to build more homes when he or she feels or believe that they are ready to do so. Yes.
Nice two-parter. So obviously, when, say for instance, I'm starting in the home, or I'm starting from the house, I know somebody, or I contact somebody from the NHBRC. They obviously then set the project, and then at the end of completion, they issue bid for the certificate of completion. So for the works that that's done.
What happens is, in practice, the municipality gives the homeowner an occupation certificate. So our services will be built into occupations. It will not be a certificate that the homeowner gets from NHBRC. The occupation certificate allowing the homeowner to move into that home, because now the municipality is part of the partnership, and the municipality will use it for itself.
Got a question on one hand. should I purchase a house that does not have my occupation, that's occupation specific, or should I purchase a house with or without that certificate?
What you need to do is you obviously need to liaise with the municipality because they have a recourse ultimately in an establishment or in a township for that matter, not talking about separate township. It means that the municipality would have on record what has been happening to that specific home, the history of that specific home with regards to the occupation. The occupation certificate would also have been given to the previous owner. So if the previous owner, you buy a house that's 3 years old from the owner, you have the right to ask for issues. In other words, communication, otherwise it contributes. Yes. Yes.
How was it? How did it?
From the picture that is on the screen today, it wasn't totally scratched to the ground. It was a case that they had to replace those cubicles that was in the foundation with alternative material. So they didn't. But no, they didn't. It wasn't. In other words, it wasn't flattened to be able to work from scratch because of the it was literally the material that they had to replace the foundation, which was just back into alternative.
Any other questions? We're all good? All right. Mrs. Van den Berg, if you have any other questions, please feel free to ask her. She will be at her stand, and she's also going to be joining us for the rest of the day. So thank you very much. I think you can give her a round of applause. All right. Then in the next 15 minutes, we are going to be switching over to the stream for the Maya tips and tricks. So we're going to be doing a Maya demonstration for Autodesk Maya. So for those of you online, you'll join us in the next 15 minutes, and everybody else who is interested, that'll be taking place in Center 1. Thank you. All right. So for everybody joining us online, we have now got Lana up front here with us, and Lana is going to be giving us an introduction to Autodesk Maya. So Maya is one of the new exciting softwares that we are going to start training and including in our curriculums. So I'm going to hand over to Lana, and he's going to do a quick little demo for you. Thanks, Lana.
All right. So good afternoon, good morning, guys, wherever you guys are in the world joining us. Okay. So I'll just start a new project for us to do on Maya. You guys can have a look on the screen over there. At first, it will look like there's nothing on the screen, but once we do start adding in content, and then obviously we'll be making that content move in certain ways, and then we'll see how the animation for Maya works. So just as Ryan explained, Maya is a 3D software, 3D animation software. What that means is, like, we have seen cartoons on big screens, like I'm gonna say Ice Age and those kinds of movies that actually depend on 3D animation. Maya has been involved with those movies. So a few companies that have used Maya, Blue Skies Productions, they are one of the companies that have used Maya or 3D animation. And for today's tutorial or today's demo, I'll be doing a quick demo of how you can actually move something using Maya or content in Maya to make it look as if it's walking. All right, so I'm just gonna go ahead and click on new, and then we can get started with our demonstration. So for this demonstration, I'll be adding in a biped as Maya refers to it. So over here in my home tab, I'll be clicking on polymodeling, and then I'll be opening up my content browser. All right. So in my content browser, I have a few preloaded models I can use for Maya. So I have a anatomy hand, I have a hand, basic head, I have a character, a female character, alien, small alien, big alien, monster, cyclops, monster wolf, and a robotic humanoid or a robot humanoid. For this one, I'll just be using the human body. As you can see, there are other variants of the bodies as well. So we have female, male, obviously alien, and then we have like a beast character over there. For this one, I'll just be using the human body. All right. So over there is a preview. I double click it, and it will add into my screen now, my viewport. So it's added into my viewport. I close my content browser. So from there, I can now zoom out a bit using the scroller. And using my Alt key, I can navigate my viewport. So if I hold down Alt, right, left click, I can rotate. Using the scroller button, I can move it up and down. And using the right click, I can zoom in and out of the model. All right. So I've loaded in my human body. As you can see, it's just a normal body, doesn't have any features, anything like that. So what I can do now is I can actually go and give this model some muscles or make him a bit bigger, make him smaller. So by just clicking on him, and then I can move him around in certain ways. I can move him left and right, up and down. I can rotate him forward, backwards, well, any way which I can, and I can scale him either smaller or bigger. So if I move him, I just press W, and the directional keys or the directional arrows will appear. I click on any arrow, I click and drag, and that's how I can move my humanoid. All right. That's to the left and right, up and down, forward and backward. All right. Just undo everything. So they have him center again. To rotate him, I press E, and then a ball like that will appear. Again, we have an axis, a red axis, blue axis, and a green axis. So by simply clicking on any one of those, I can choose in which direction I want to rotate them, either forward or back, left or right, again forward and back, hey, forward and back, left and right, and like that. All right, that's just how we can move them around. Then we can scale them. So using the R key. So again, we have our directional keys or directional arrows or directional axes. So I can scale him to the side, to the left, to the right, right? If I just zoom around him, Alt key. So As you can see, if I scale it like that, you guys can actually see how it scales. All right, looks normal again, but it's not. Let's just undo everything we just did, getting back to normal. Okay, right. So that's some of the hotkeys we can use. So the nice thing about it, it's all inline. All our move tools are inline. So WER, WER, that's how we can change the object. Okay, so do remember when you are or when you do want to change an object, you do have to click it, make sure it's highlighted in green, and then we can do those functions that we actually want to move and rotate it, and so on and so forth. All right. So for this one, I'm going to add in some muscles to my guy. So I'm going to use the sculpting functions, and then I'll be using the lift a surface. All right. So again, I need to select the polygon mesh. So I'm going to select my humanoid or my body. I select it, and now I can actually go and give him some muscles. So I'm just going to zoom in, rotate and zoom in, give him some nice biceps. All right. So that's not what I want. The hardness of my brush is too much. So I'm just going to Control Z that. And then using my scroller, I'm actually going to go and lessen the hardness of my brush so that it's more fine-tuned, right? So when we saw before, when I was using the sculpting tool, it was more of a hard sculpt and not a soft sculpting. You'll see now what I mean. So if I do sculpt over and lift the muscles now, it looks much smoother, right? To see the actual difference, I can see it from the side. So you can see there's actually muscle now, right? So there's muscle, right? But now I need to do it on this side as well. So I can click on that side. I can lift the muscle, give the guy some nice muscles. So over there, give him nice biceps. So there we can see we have actually given him some biceps. We can actually give him a chest. As you can see, give him some chest muscles. You can see it's flat from the side. So from the front, let's give him some chest muscles. Let's build him up a nice chest there like that. Give him a nice chest. All right. All right. Give some six pack there as well. Some muscles at least. All right. Now if we go back to our side view, you can actually see that we've given him a boop with some chest muscles. All right. Obviously, you can fine tune these more with the thickness and the hardness of your brush. But in terms of getting the symmetry correct, I'm just going to undo everything again. So I'm going to take all these muscles away now. So again, flat chested, no boopy. Now we're going to make sure that what we do on the right side will be implemented on the left side as well. So whatever we do on the right will be implemented on the left as well. So I'm going to change. So over the top here, I'm going to change my symmetry from off to the Y. So world Y. So now if I go and change the left arm, it should change on the right arm as well. Okay. All right. So object X. So you'll see that on the right arm or the left arm, that's where my brush is. And then on the opposite side, you'll see there's a square, a small little dot square, right? So when I add in muscle now, I'm starting to sculpt. You shall see that that side also starts sculpting as well. So if I start clicking, it adds in muscles on the other side. It starts sculpting on the other side as well, all right? Let's just see there. So over here, I sculpted on this side. Let's check the other side. What's happening there? There's a bit of muscle there now as well, right? Let's do the chest as well. All right. So let's do our chest. So I want to come down the center. You can see there's my black dot. Come down the center. There we go. Right, so let's look at it from the side again. So now you can see I've given him some nice chest muscles. And there we have nice chest muscles. So now what I want to do is I've given him muscles. Now I actually want to take away some of the muscle over here because it sort of looks like he has a poopy coming out there. All right. So what I'm going to do then is I'm just going to hold down control, and it's going to allow me to sculpt in the opposite direction, meaning it will take away now. So if I start clicking like that there, give him a nice V like that. Right? That's how it looks like that over there. Right? So by taking away, it sort of looks like I added a six-pack, and that's how you can sculpt. All right? So we have sculpted, give him a nice little chest, some six-pack muscles over there, and that's how we can sculpt an object. All right? Now let's get to some animation parts. So let's try and make this guy walk or move his arms and his legs around for a bit. All right? So from here, we're going to use our rigging tool now. So again, where we found our sculpting tab, just next to that, we have the rigging tab. All right? So we all are just going to automatically add a rig to this body, and then from there we can make it move. All right? So in the rigging tab, what I'm going to do is quick rig. All right? A dialog screen will pop up and it will ask me to select the character mesh. So for this, I'm just going to select the humanoid. Select. So I'm going to select the humanoid and I'm going to click on auto rig. All right. So now I've added a rig. Pardon? I've added a rig to my human or to my human body, and you'll notice that small circles or a skeleton has appeared on the inside of the human. That is the skeleton that I'm going to use to make this person or this object move within Maya or the viewport. All right. I'm just using the scroller to zoom there. So let's zoom around and look at it. As we can see, the skeleton is completely on the inside of the humanoid or the human body. All right. And then over here on the controls tab or the human eye key or the eye key, this is where we can actually go and select these parts within the skeleton. So this is just like a basic outline of the skeleton. You'll see that if I select the shoulder part or the shoulder connection, it will highlight in green, and now I can actually go and rotate or move that part so that it moves the entire arm. What I mean by that is if I press R or E for rotate, and I rotate it on the yellow axis, I can actually make it move like that. All right. So as you can see there, make it move left and right, forward and back, right, up and down like that. All right. So let me just move around like this here now. Right. So that was the left shoulder, the right shoulder. Let's do the left shoulder now as well. So I'm just going to rotate it like that over there. That's where I want it. Right. I'm going to zoom around. Make sure this is the way I want it here as well. Right. Now I've moved my human's arms next to him. And now I'm going to make that my first scene. What I mean by first scene is I'm going to start making a series of, I'm going to start taking a series of screenshots, and actually as the screenshots go along, I'm going to make an animation. So screen by screen will eventually add up to a few minutes of movement or film, basically. All right. So that is my first scene. This is my first scene that I want. Just going to rotate it like that. So what I'm going to do is to create my scene or the shortcut for my first scene, I'm just going to press S, and I've created my first scene. All right. Doesn't look that way, but I have created it. At the bottom over here, I can see how many frames I have. All right. So this is my frame bar over here. I'm just going to move this across here to get more frames or more seconds into my scene. And I just want to see the first 30 seconds basically, all right? Or first 29, 30, all right? So over here, I'm just going to press S again. That's going to be my first scene, all right? Then I'm going to move over to my second or the 8th second. Let's go to the 8th second or the 10th second, all right? So now I'm going to say within my first 10 seconds, I want to take one complete step. So I'm going to take one complete step. It might sound like a little, or one step might sound quick, but when working with Maya, it's a lot of intricacies and moving things around. So now I have to physically move my human, make sure that some of the knee joints, arm joints are moving according to how actual human would move. All right. So now I'm just going to move my human forward. So on the pelvics over there, I'm going to move him. Notice that my feet will stay where they need to be. All right. Let's get W like that. All right. So around about there is where I want my body to be at. And then now let's move the leg. All right. Let's rotate the leg. Nope. Let's move the ankle. Let's move the ankle. Right. So we've moved our foot forward. Let us rotate the ankle at the back. All right, so I have my right foot the way I want it. Now let's move to the left foot. All right, so I have my feet in place now. Now I'm going to just move my arms the correct way I want it. All right, so let's go with this arm first. The right arm. So the left arm as well. Ooh. Right, so I see my knees out of place over here. I'm just going to move that back where I need to be. So using move tool, just going to move my knee back to where it needs to be. Same for the other knee as well. Seems that one is also out of place. There we go. So now it sort of looks like my human is walking, right? Right, so at the 10th second, I'm just going to add in the scene again, right? So from the first scene, the second scene. Okay. All right. So my first scene did not save. So now I just need to move it back to where it needs to be now for my first scene. The nice thing about Maya is as soon as you have saved the scene, you don't need to go back and recreate it. So I just need to make my scene again properly or save my first scene again. All right. So let's move that back to where it needs to be. All right, so for me to move it back to where it needs to be, all I'm going to do is just in the, in the channel box, I can just change my X, my Y, and my Z coordinates to the original spot. So I'm just going to make that 0 again. All right, thank you for bearing with me, guys. So that is my first second that I've just created now. And if I switch over to my 10 second, you'll see that it's sort of moved in a way. All right. So that's how my humanoid or my body or my person would look at the 10 second. That's how they look at the first second. All right. All right, so my scenes have been created and saved. So now what I'm gonna do is I'm gonna take my second step now as well. So from there, it's moving the hands, the arms. It's moving the arms and the legs and the feet. So let's move those again. All right. So let's do it like this. Let's move everything forward. W. Let's move everything. That's not where we were. So we want to be. All right, let's move our legs now. All right, and that's the scene we have created at 20 seconds. So if I just quickly go and play back everything. So from second 1, play back everything. Sort of looks like my human is walking. So the nice thing about what Maya does is at certain scenes you can create um, how the object would look at that specific scene. Right? So at scene or the beginning at scene 0, nothing could be created because that's where it started. At scene 1, we started seeing movement. All right, so that's how we actually got in or the animation object to start moving in a certain way. At scene 10, we took our first step, so we know how it looks. Or if you have a picture or visualization of how a certain animated object would look at a certain scene, we created it. And from scene 0 to scene 10, Maya would create everything in between. So as you can see, it's smooth animation in between. So all you have to go and do basically is add in your certain scenes at certain seconds, basically. So you can create a scene create a scene at the 10th second, depending on your FSP. And then from the first second to the 10th second, Maya created everything in between. So you don't physically have to go to scene to second 1 and create that specific figure. Scene 2, create another specific figure. All you have to do is from scene 0 to scene 10, create. So at scene 0, do nothing. Create the first scene at the first second, how it would look in the beginning stages. At the 10th scene, create how it would look if you took your first step. 20 seconds later, you can take your second step. And that is how you can do the animation process for Maya. So again, let's just play it from the beginning. All right. So it does look like he's kneeling there at first, but that's just how it looks or how the animation would take place. All right. So let's try it again. Oh, all right. Right. So that is basically Maya in a nutshell. So if you're starting in the beginning stages, that is how it would work. Um, Obviously, if you change the FSP of the animation, it would give a more finer tune towards it. So currently I'm only at 24 FSP, but if I increase it to say 50 and I play it from the beginning again, let's look see how that would look. And we play the animation. Does look like the guy's actually walking normally, but there are still a few kinks that we need to work out. So as you can see, he's moving down a bit. So let's play that again. So let's see the guy walking again. All right. Let's try some more FSP. So that was at 50 FSP. I know the more frames per second you give it, the smoother the animation will look. So let us try 120 FSP. Let's play that. Looks great. Looks great. Let's try 240. All right. So as soon as you start playing around with the FSP, the animation will start to look more smoother. So the higher the frames per second, the smoother the animation will look. Obviously, we can add in more steps now. So I'm just going to change mine back now to 24 frames per second. No, 24 frames per second. And now I'm going to add in another step. So we can actually take 2 steps now. Right. So unfortunately, that is my time. I'm just being made aware of the time now, guys. So that is just a quick preview on Maya. If you guys want to learn or do more, I would suggest downloading the software. I'll see if I can maybe get another slot in with you guys tomorrow to do some more Maya demonstrations. Maybe do something different this time. And yeah, thank you guys for tuning in to the demo for Maya. I'll be giving back over to Ryan now, and he'll take you through the rest of the program. So just once more, I just want to play it for you guys again. Just doing the animation again. I know it's a bit rough, but let's just do it again. I'm gonna take it back to let's do 240 FSP. Let's play it from the beginning again. And that is Maya for you guys. Obviously, this is just the tip of the iceberg. As you go more into it, you can start creating various things on Maya. Thank you.
All right, thank you very much, Lano. I think that was very informative and a good insight into one of the new softwares that will be introduced into CAD4ALL's qualifications from 2023. So we are going to switch back over to the talks now. In a few moments, we will be hearing from Imran. They are the creators of Zen 3D Filament in South Africa. They're going to take us through their product range as well as a bit more details on exactly how 3D filament is produced. So we'll see you in the next 2 minutes. next up we have the lovely ladies from Imran Holdings. So I have Melissa and Jeanette up front with me. Now, obviously, 3D printing is nothing without filament. And these ladies are producing the filament here in South Africa. They are the producers of Zen. So that's the 3D filament that you see on the table there, as well as what the 3D printing with. So I'm going to hand over to them. They're going to give you a bit more information about what they do, the type of filament they produce, and then they're also going to show you the production process they are.
Can we get a quick show of hands? Who of you actually 3D printing already? Or have you been doing some 3D printing? Okay, so the rest of you are still interested in it. Yeah, so Ryan's already introduced us, Melissa and myself. So we, and currently we are doing PLA presentation.
Sorry about that. There we go.
So the filament that you see out there, probably a good chance that either Melissa or myself have made. So
Sorry.
There we go. So I don't know if you've heard of the term additive manufacturing. That's what 3D printing falls under. So subtractive manufacturing, that's where manufacturing really started. And that's the big difference between subtractive and additive manufacturing. Traditionally, if I had a block like this and I wanted to send it to a manufacturer, the manufacturer would then need to find a piece of material and they would subtract out of the material to make their part. And then turn the piece over, and if it was hollow, then the inside of the piece would be made. So as you can imagine, when you finish manufacturing something like that, you end up with a lot of waste. Additive manufacturing, on the other hand, you start with nothing, and then your part gets built up piece by piece. So in terms of wastage, it's a great, a lot less waste that happens. So this is just a quick visual overview, like when you've got subtractive manufacturing, you've got a tool, and you take out the material, and then additive you add on. So what are the big benefits of additive manufacturing? So in terms of customization and personalization, traditionally if you just made one of in manufacturing, it would be really expensive. If you've ever had something made one of, you know, your machine, you need to set up, there'd be a lot of tooling involved. For every single part that needs to be machined out, there's potentially a different tool that needs to be used. So the setup process is very expensive. Whereas with additive manufacturing, it's one machine, one type of material, and then you can create quite a complex part. There are obviously with traditional manufacturing a lot of limitations. So there's also a lot of, you can get into market in terms of prototyping and trying new products, you can get into the market quite quicker, a lot quicker. There's also enabled distributed manufacturing. So if you wanted to have some prototype made and you had a whole lot of different branches, say you're based in Cape Town, Joburg, Bloemfontein, you wanted to have the same prototypes made at your different branches, you'd be able to very easily send those files out and have the manufacturing done at multiple locations. So in terms of additive manufacturing, there are 7 different types, and I'll go through them very briefly. Where we fit in is material extrusion. So the first is vat polymerization. This is the resin printing. So I don't know if you've seen the little, you've obviously seen at Netram, the little Notre Dame model that they had, that's made with resin. So how that works is there's a laser beam over here, and then it cures each layer. It cures it, and then it builds up your part like that. In terms of the detail, you can see like there's a lot more detail that can be made with your resin printing. Powder bed fusion, this is really where they use any sort of powdered material, can be ceramics, metals, and that sort of thing. And then they use a laser beam, and then they basically melt the powder on the area that they want to build up, and that gets done layer by layer. Binder jetting also works with the powder. The only difference here, instead of using a laser beam, they would use then a liquid binding solution, and then each layer gets built up with as the liquid cures. Your material jetting, this is very much the same as what your traditional 2D printer works. You know, it goes forwards and backwards, adds ink on a paper. The same sort of thing would happen here with like your waxes and photopolymers. Directed energy deposition, this also works either with a metal wire or with like a powder of some sort. It's also got an electrical beam, and as the material is brought in, the electrical beam then fuses it onto the various layers. Sheet lamination, that's quite self-explanatory. It's where it gets built up either with sheets of paper, foils, and that sort of thing. And this is really where we focus on the material extrusion. So material extrusion, you can be done with 3 different types. You can either have like a slurry or liquid-based material. There's the filament, which is what we focus on, and then there's also, you can get a pelletized type of material, which you use with a screw, and then it also extrudes out. So this is a close-up of what your typical material extrusion would look like. If you've had a look at any of the 3D prints, you'll see that very particular line by line as the material is built up. So you can create your settings so that they become thicker and smoother, but you're always going to see some level of lines being built up. So at Emeren currently, what sort of materials are we doing? We're doing mainly the filament. We are going to start looking at doing a pelletized version of the filament as well. So those people that have 3D printers where you throw the pellets in directly, and then it basically extrudes them. The process that we do, your 3D printer will do, it just melts the plastic. So what are the 4 types of filament currently used? These are your big 4 used in 3D printing today. PLA, which is really the majority used filament, and that's why we've decided to start with the manufacturing of PLA. You've got ABS and PETG, which is your harder type of filament, and then TPU, which is your more rubberized, elastic type of filament. So PLA, which is polylactic acid, is really what they consider the king of 3D printing. It's a really easy to print with filament. It's best suited to beginners. So if you're starting out in your 3D printing journey, this is the filament that you're going to start with. It's also made from organic materials. So it's made from cornstarch or sugar, and that's why they say it's biodegradable. So a lot of people say, is my filament compostable? There's some people that claim their filament's compostable. So not going to get into all of the technicalities, but compostable basically means if you put something in the soil, 30 days later, it turns to nothing. So definitely not going to put your 3D print into the soil and 30 days later, it's going to turn into nothing. It does biodegrade after a period of time. There do, however, need to be certain conditions. Normally with industrial composting, this happens. So a certain amount of heat needs to be applied and a certain amount of microbes in the earth. The PLA also doesn't have any toxic fumes. It hardens quickly, it's acetone resistant, and then it doesn't require a heated bed or Kapton tape. Now that's a sort of adhesive which you will use to keep your print down on the print bed. There's also minimal thermal tension and deformation. So what sort of stuff would you print with PLA? So it's best suited to cosmetic prints. So you know, your kind of desktop toys and your fun stuff. You'll see we've got a lot of fun hobby kind of prints out there. Prototyping, so if you're in engineering and you want to prototype new kind of parts, it's ideal for that. Props, if you speak to Netram, you'll hear they've done a lot of props for the movie industry and that sort of thing. So like you can imagine when these guys need one-off props, they 3D print all their parts. Marketing displays, exhibition signage, pastry molds is a big cookie cutter market. The ladies love doing fun cookie cutters. printer tools and jigs, and all kind of low stress applications. So here's just some samples, lots of cosplay that's really big in the industry, and then your functional prototyping, cookie cutters, things like jigs, you know, you can print an easy jig for yourself. So what are the tips when you want to print with PLA? So really important to check the temperature on your print. Each PLA's got different, depending on the mix that the manufacturer has made, it will have a different print temperature. So our two ranges, we've got the minima and the ultra. So our minima prints at a lower temperature, 190 to 210, and then our ultra prints at a higher, slightly higher temperature. So if you don't know what the temperature is, we normally say start at 195 and then move up or down in 5-degree increments. You also need a heated gold plate, which is the plate that your filaments starts printing on. So sometimes something like this happens. It's called stringing. It's basically like, I don't know if you've ever used a glue gun and then you glue something. When you lift it up, it leaves that trail like that. It's the same sort of thing. Sometimes it means that your printer might be set too hot. It's also, we can also fix this by enabling your retraction settings. So you either get your retraction speed or your retraction distance, which you can modify. If you guys are interested in a little bit more detail on that, we've got a Zen YouTube page where we've done a video, and then Brendan from NetRam will go into all the details and what settings you need to put in there. Sometimes your prints like this will also not adhere properly, so you'll see gaps in the different layers. This basically means that your temperature is too low. So just increase your temperature by 5-degree increments, and maybe have a look at your fan cooling as well. It might be that your fan is cooling the filament too much. Then really important, you always need to keep your filament dry. So if you see all the filaments standing out here, if it's left out for a very long time, you'll see that it starts snapping, and that's because it's drawing moisture from the outside. So really important that you regulate that. There's a couple of things you can do. You can buy a fluoride dehydrator. So this is one that NetRam uses, and they've printed themselves a little extender. This extender here, that's the lid that normally sits on there, but they wanted to add multiple filaments into the dehydrator, so they just printed themselves a little extension like this. You can also put it into the oven for at least an hour at 60 degrees. Important not to put it on too hot, especially if you've got filament on a plastic reel. We've had some melted filaments before. You can also store the little desiccant sachets that you get with your filament, or any, if you buy shoes, whatever, you'll get those little desiccant sachets. Keep a whole lot of them and pop them in a box. It will help draw out the moisture. And then obviously you can also use, failing that, you can use a box of rice. Like you would pop a few grains of rice into your salt. Sometimes the same principle applies. So these are currently the 14 different standard colors that we've got in our PLA minima range. This is our kind of entry level, easy to print with range. We also have 5 silks and 2 metallics. And then we've got our own in-house spoolless range. So the spoolless range is basically, you know, there's a lot of waste these days. We're all about sustainability and, you know, protecting the environment. So a lot of times the plastic reels just end up on a junk pile, which is why when we launched the Zen brand, we decided to do it on a wooden reel. But these spoolless ones, you would basically print your own sides, and then each time you can just pop your sides on, and then when you finish the spool, take them off and reuse them. And then our ultra range is our more premium range. This is quite a hard filament. We like to say it's one of the toughest PLAs on the market. In strength is somewhere between traditional PLA and ABS. So I'm just going to go very briefly through the other filaments. This ABS, this is one of the really strong and durable filaments. It's really resistant to high temperatures. It is a bit more difficult to print with ABS because it is prone to warping, and it also has, it gives off toxic fumes, so you need to make sure that you're in a well-ventilated area, or that maybe you're printing with an enclosure. And it also requires quite a hotter temperature to print with and a hotter heated bed. So the sort of things that you would print with ABS are really items that are frequently handled, dropped, or need to be heated up a little bit. So things like tool handles, automotive trim components, hardware, electrical enclosures, cases of project enclosures, high-weight tools and action figures, gear parts, and parts exposed to UV and heat. Tips for printing with ABS, as I said, the temperature needs to be controlled quite a lot. So, building an enclosure or having a printer like the Sir Moon, which you'll see Netram has out there. This is one of the new generation printers. That can really help with that. You can also install a filter that can help get rid of the toxic fumes. Then ABS tends to lift quite a lot off the print bed, so it doesn't stick very easily to a glass or even a rough surface. So we normally suggest using a print adhesive or even hairspray. And then in your slicer settings, you can do something called a raft or a brim. So that's this very light section around the print here, which you then break off afterwards. It helps create a bigger surface area for your print, so it helps to keep the print down. Then something I mentioned earlier with the PLA as well is controlling your print temperature. Obviously, ABS prints at a higher temperature, it starts at 225. So what you can also do is print yourself a little print tower. These files you can find them online. And then you start at a different temperature, so you'll start at 190 and go up to 230. And then each section is printed at a different temperature. You can't really see it so well here, but you'll see like here's a lot of stringing, so then you know that filament at that temperature is too hot. So you just have a look at this afterwards, and then you'll see where the print looks best, and that's really where you should be. That's the temperature that's ideal for your print. Again, keep your filament dry. That's pretty much with all filaments. Then TPU, that's our one that's got combined properties of plastic and rubber. So they're they're bendable. You can, anything that requires a bit of elasticity. It's also very resistant to oils, grease, and a variety of solvents. So there you'll see, I don't know if you've seen any of the shoes that have been printed with TPU. It's because it's flexible, it can move, so phone covers, that sort of thing. Orthopedic models, medical and wristbands, automotive seals, gaskets, plugs, tubes, and protective applications can be done with TPU. It's also printed at a higher temperature between 225 and 250. A direct drive extruder is recommended. Your heated print bed is at 50 degrees. Recommended that you use a cooling fan. It's not necessary to have an enclosure, and you do need some adhesive tape. Last filament is PETG. PETG is basically a glycol modified version of PET. So PET is what you print. The majority of the water bottles are done in PET. It's a really good, rigid filament for printing. So that and ABS, if you need some really hard-wearing filament, that's what you'll be using. The big difference between PETG and ABS is that this one is food grade. So if you have any applications that need to have food grade stuff, this is the one that you'll be using. So yeah, in mechanical parts, robotics, artistic prints, bottles, covers, medical and food grade applications, as it is food safe. A few tips for printing. That's prints at even a higher temperature, 235 to 250. Always use a fan with PETG. Your retraction speeds need to be slow at 40 millimeters per second, and your bed temperature is pretty hot at 80 to 100 degrees. Now I'm going to hand over to Melissa. She's going to take you through the how it's made section of our production process.
Hi everyone. Thanks so much for coming today. So I get to have the pleasure of showing you what we get up to in the factory and how we actually produce the filament. So this is just a very short clip. I don't know if any of you saw it on the Zen page. So it's just a very short clip of how we do it in our factory, how the Embrun way of doing the filament. And then I'm going to go into a little bit more detail as to each part of the manufacturing process. Okay. Cool. You notice some parts in there that we leave out. Okay, so the basic process that we started with is heating up our machine. That takes about an hour and a half to 2 hours, just to make sure that the machine heats correctly, the water's at the correct temperatures. Then we have our raw material that we need to dry and mix up. So the drying is a really important part in filament manufacturing, specifically PLA. As it does absorb moisture quite quickly. So we dry our material for at least 4 hours before we can actually process it. We also then have a drying unit where once the material comes off the machine, it then further dries in our drying units, just to make sure that the material is absolutely dry. If your material is not dry enough, then you can experience quite a bit of snapping, and that's not great. Like you're halfway through a print and it snaps and you just off the print all over again. So as Jeanette said, very, very important, specifically with your filament, then once you've used it, to keep it dry afterwards. Okay. Then we mix it up. Then we have the actual extrusion process where we run it through the machine, we do the winding, and then the packaging. Okay, so as Jeanette said, we focus mostly on the PLA. So that is how it comes, the raw resin. That's how we get it. And then we have our master batch, which is also PLA based, and that's the color that we then add in. So it's two separate components that we add in the mix together. So the raw material is about 96% of the filament, whereas the master batch is a really low dose because it's quite potent. So it is mostly a raw material filament. And then you have your additives that you can add in. So the basic mixing process is the raw material plus the master batch plus your additives, then we mix it up. So obviously each manufacturer will have their own mix, their special mix that they use, and their own additives that they use. So it's a big hidden secret in the industry as to who's doing what with their filament. Okay, so this is the basic layout of the machine. So you have your hopper, which we also then keep at 60 degrees to make sure that the material stays dry while we're busy processing the material. We don't like it to be cool, and we obviously don't want any wet filament going in the machine. So it enters into the hopper, goes through the barrel. The barrel then contains the screw. So this is the key part of the extrusion process. Basically, your filament comes in. The screw is slightly tapered, so it's crucial that it stays tapered, as it needs to go from a high volume where it gets compressed. And it's together with the mixing of the screw as well as the heat is what then makes the molten plastic. That then comes out of the die through the hot tank first. The hot tank is about 60 degrees. Through the cold tank into the drying device. So we use compressed air to dry off any water filament. You do not want wet filament on a reel because it's going to basically start breaking down, which is not what you want. It goes to the laser. The laser then reads the diameter through the haul-off. So the haul-off is basically a winding machine that feeds the filament through, and then onto the laser, and then onto the reel. So between the haul-off and the speed of the motor, that's what basically sets the diameter of the filament. So the haul-off is constantly adjusting itself to meet the speed of the motor to keep the diameter consistent. And then we obviously get the reading through the laser. So this is just a very simple video of the startup process of actually getting the filament through the machine. We don't have an official MRIN video from start to end, but we did use this quite a bit in the beginning just to make sure that our process is improved. So this is one of the better videos of the actual startup process. So his machine is slightly different to ours. It's not quite the same, but There's lots of parts of it that is the same.
All right, let's walk through the whole process here. Got the filament coming out. Go ahead and drive the tank in. Get my cutters. Get a little piece of scrap here. I'll use this to pluck with. And now I will pluck the filament. And now I have to walk down the line at a constant rate. Pretty much until I get to the cold tank and it sets up hard. Now what I'm going to do is in one fail motion, snip it, clean it off, feed it through, over the laser. And now we're waiting on it to all settle in. Get past all the bumps and everything. And that should be pretty good. It's setting up just fine. Pushing the filament into the water for now. We'll go and tidy that up here in a second after I get this all prepared. So the filament's coming out now. I'm in a decent range, but we're going to throw it off anyways, so it doesn't really matter. And now what I'll do is in one fail motion, do this, and wind, 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 and just keep doing the little dance over and over.
I haven't done this part yet.
And this is threading the accumulator. This is where the buffer goes. Almost there. And then while it's still coming through, I gotta come over here. And then I start up the winder storage. And now the accumulator is gonna go back and forth at that tension. I'll cut off a little bit of extra. And now what I'll do is I will thread this machine, which is the counter, thread this machine, which is the winder, and grab me a trash spool, because unfortunately this first one will be way out of spec. Do my numbers resets. I have to do all of this at a very specific time just because now that's winding, the accumulator's building. Now I come down here, I up the speed to what I'm going to run at for the day. The alarm should start going off here soon. But I'll come down here and work on getting this in the range. And the accumulator is still spooling out, which it shouldn't. So I need to slow it down a bit. Because I can't really waste too much filament there. And now that that's going just fine, let me thread it. There we go. Let me put it underneath automation control, and that should buffer up here soon. As you can tell, it's definitely out of whack, but we're getting there. That's pretty much why you end up throwing away the first spool of the day as you set up the machine. Now let's get our dies into place. These dies will help form it all the way down the line and help keep it in round. Turn on the fan. see it's a little out of tolerance, but it should start bouncing back here soon. Numbers getting closer and closer together. It's starting to get to decent numbers. So it's going to start settling in here. Let's make sure the lasers align. There we go. And that should take care of that. And that is going to improve a little bit more. What?
It's not there, it just carries on, it's trying to sense on the diameter. So that's the most critical part of setting up the machine in the beginning, because that basically sets the machine for the rest of the day. So you need to get that spot on, you need to get the diameter spot on, and then the machine runs pretty beautifully for the rest of the day. So that's a key critical parts of starting up the line and the start of the day.
So you have load shedding.
Then you start that process 3-4 times in the day. Okay, then this video is just a quick run through of what our machine actually looks like. So this is actually from the manufacturer of the machine. So you can just have an idea of what our machine looks like. That's the hopper. It goes through the barrel. That's the compressed air sequence. Laser. Portal. Emulator. The wire. In a nutshell, that's what it is. So yeah, so it goes to the binder, then the vacuum bag, this nickel pouch, plastic is on, and that's our filament process. It's very short. Simple.
But maybe you have a bit more appreciation next time we use a roller filament, what's all gone into making that.
Did anyone have any idea of how it's actually manufactured? Yeah, it's quite interesting when you start looking into it. You think, oh, it's just a simple winding on process. Well, there's a lot of technicalities involved in it. So, thank you.
Any questions?
Why does an old person have to be restarted?
So, well, the motor shuts down, so then the filament doesn't come out of the machine anymore. So then once the machine off, the motor starts cooling down as well. So we need to then start reheating the motors up, reheat the water, compress air going, pull it through, start the whole process again. Yeah. The filament will just stop running out of the machine and then it shuts down. Yeah. So we just need to stop the whole heating process anyway.
So, I noticed that there are some filaments that are like open texture as well. That are sorry, but
The texture,
yeah. So
Does it go through the whole same process or is there different? So it's just different components. Yeah.
So it's just based on it's just based on the material and the mix and how it's going to come out. So PLA comes out really nice and smooth and glossy, whereas other filaments will come out more rough and texture.
Okay, then I have another question. So say the power goes and you guys have to do some more things. You guys specifically have the old machine. Do you guys do this one?
No. Okay. So whatever materials run through, depending if we're doing a color change, we basically run the color through the machine before we add the new color, because obviously it's constantly mixing in the screw. So once the power goes off, that material stays in there, but it just needs to get remelted again.
Yeah, it hardens up. It basically becomes a chunk of plastic inside. So you can imagine, like, it's not really easy to clean that out afterwards because it's a solid piece of plastic that's inside.
Yeah, it's always
and to clean it out, you actually have to take it out at temperature. So we've cleaned it out once, but it's really hot. That plastic is like, I don't know how many degrees is that?
We have to keep it at up to 210.
Yeah, so it's not a pleasant process to clean it out. Yeah. So that's why we're very careful about what we put in the machine, and that's why we only run PLA through our machine, because we can't risk. You imagine like the barrel, the screw that's in there. If one little granule, you can see they made out of little bits and pieces. And even like with the filament, we have to be very careful with the color. We have to vacuum it out afterwards because little particles can get stuck. So if you've got like different sorts of different materials going through there, it's possible you can get contamination. So we like to keep. It's a very expensive, high production machine. We can do about 140 to 160 on a single shift in a day. We can produce. So that's why we only run at the moment like batch production. We can do a whole month's production in a week, 2 weeks of the month, depending how long we're going to run for.
So we run at about 80 to 85
Say your power stops and you only got halfway through a reel of the filament. What do you do then?
So then it becomes scrap. There's nothing we can do. Well, what we do is I haven't. So we have to keep that. Like we've got partial reels, we have to log those, and then obviously our color changes as well. We can't sell like when the color transitions from one to another. So we do keep those, and then we sell them to our distributors as prototyping. So when they need to do like special prints. And they're not really worried about the color, So at the moment, we've kept our partial reels. We use it for in-house printing and testing and that sort of thing. We may one day start selling it, who knows? But we have to be very mindful about way. So what we started doing now as well, because you can see when they start up how much a filament actually comes through and is wasted. So we've now built ourselves a pelletizer, and then our scrap that comes off, we now regrind up, and then at a later stage, once we've tested it, we may come up with a repurposed filament that we've kind of used our scrap. It's not scrap, it's just filament, that we've reground down. But we first need to make sure that the filament's good and that it'll be a decent scrap and decent quality before we put that into the market. But that will be a part of our sustainability, as I say, we're going to do these things in stages. Yeah.
All right. Thank you very much, ladies. I think we'll give them a round of applause. Myself, I've been lucky enough to visit Emran at their factory, and it is literally like being a kid in a candy store if you own a 3D printer, because all of those colors in front of you, and actually seeing how they produce it and how the machine works, it is quite an amazing process. It's something that you don't think about every day of how it's exactly made, so it's definitely something that's very interesting and that we are very glad to have them on board. So thank you once again, ladies. We are going to break for lunch now. So the exhibitors are going to have some lunch, so we're just going to close down for an hour. Everybody online, you can join us back in an hour, then we will be going through the exhibition hall, actually talking to our exhibitors, seeing who is here, and then we will be starting up for the last talks again later this afternoon. So thank you very much.
What's wrong with you?
No, we're going to get food first.
Sometimes there's no one else who loves me like you used to. Sometimes we're not ourselves, there's no one I can turn to. And I know all the feelings that we shared out in the past. And I know your relationships are never meant to last. And I'll take some time, but I'll be alright. Moving on, we're moving on. I know times are tough, but I've had enough. Moving on, we're moving on. Sometimes there's no one else who loves me like you used to. Sometimes we're not ourselves, there's no one I can turn to. And I'll take some time, but I'll be alright. We're moving on, we're moving on. I know times are tough, but I've had enough. Moving on, we're moving on.
At CAD4ALL, we have a student representative council. We are the group that will be representing you if you have any problems or voicing your voice and your complaints to the lecturers and also to other students. We make sure that the student life keeps on going within the campus. Amber van der Westhuizen is the president of the council. Kerzaan Swarts is the vice president of the council itself. Other members of the council are Elismarie, Eunice, Minion, Paul Fransman, Matthew, Shati, Iman, Marnay, and Mercedes. We stretch out throughout the whole campus, including online and Claremont. The students from the online and Claremont campuses join via online to Tiger Valley, where we will conduct our meetings every Monday morning.
Bloody Samaritan, protect my energy from your bad aura. Now my pastor say I be my healer, everything
Within our campus, we have student fun days.
You gotta be careful with a dynamite stick. Summer gun, she's fun to handle. She packs a punch like a Roman candle. She's a pack of black cats in a red paper wrapper. My little darling looking firecracker. Might not ought to take a roll in the hay, 'cause we burn the barn down one of these days. We're a match made in heaven and you.
Sweden! Sweden is not in Africa!
Put your head on my shoulder.
Hey. What's up, man? What's your problem, huh?
What are those?
What are those?
Go, 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 yo, go, go, go. Hustle.
We have set a system with houses within our campus that depend on who wins and who loses. With this, we build points that the campus students can buy things with, like say extension for days on their work, or even for extra marks, like an extra 5%, because you never know when you need it. These days are set up so that students can feel home, so that students can feel that they have a family within the campus. This is to bring students closer together and also to make sure that a student life can be generated throughout campus. We have set these days in place so that students can build a relationship with each other, so that they know if they are struggling academically that we can help each other even on the hard days. These are the fun days, and we are here to build each other up and have fun. We always work in conjunction with our lecturers to make sure that they know what our events are. These events are laid out by the lecturers and approved by them if we can get a day where we can just have fun and relax. These days are set out so that we can learn to know each other better. We try and encourage students to always join in on the fun days. These are the days that you won't forget from campus. Sometimes you would forget your academic days, not advised. But always remember, the fun days are the memories you make with your peers, and one day you won't ever forget that. Good day, everyone, and this is how I will be explaining the work environment around CAD4ALL during a week simulation to give students a process over into the working environment from campus life. Students were given a day of work where they would start at 8 a.m. and ended at 4 p.m. During the day, they would be given an hour break as a lunch break. Students in this time would do different projects throughout the day to complete. When completed, the projects would be looked up and would be managed by the lecturers themselves. Workstations were set up throughout the campus by lecturers to simulate the working environment outside of campus. Students are hereby prepared for the working life outside of campus. But working with people they don't usually particularly work with, but they now work together as teams to create and finish certain projects by the end of the day. Students were also given the opportunity to rework some of the projects that had been given to them throughout the year. These projects were not only the main focus, but they would also be working on new projects that was given to them throughout the week. Students working on these projects have now found new elements that they can better their work on, and also by using the new projects as a guideline to better their work throughout the year and when they go into the working environment. During this time, different projects would be thrown to students by doing details to doing plans to doing different types of drawings throughout the week. This is to give them a sense of an idea of what it is to work in industry and not just working on one project and expecting just to do that specific project itself. A lot of students have given the insight that this week of projects have given them the sense of feel to work in industry. And some of them have actually gotten the opportunities to work at companies today. These are experiences that won't be built always. And this is the opportunities that CAD4ALL are willing to give the students that are coming in every year. The campus also does an orientation week where they give all students a sense of working together as a group. All students are divided in between all classes right across the campus. These projects are given to the students to see if they can work together with each other without any hiccups or even doing teamwork, as when you go into industry, you would never know with who you are supposed to work. Also, when students are working together, we try and encourage them to learn from each other and not just to do all the work by themselves, but to learn each and every student in the campus what to do and how to do things. Maybe learn them a new skill or learn from each other of new things.
Lovely to be here this morning. We currently here at Expo, which is one of our flagship schools for technical education. With COVID in mind, the fact that we can't have face-to-face training, we thought to contact CAD4ALL as a part of a WCD in order to do training online. Not that we can't have it face-to-face, because if you're distancing and you don't have a lot of either teachers or learners in a room, it can happen. And I'm glad that we could sign a memo of agreement between WCD and CAD4ALL, and I know for a fact that it will be a long-lasting partnership.
Yeah, well, I think we were very grateful for the opportunity to get CAD4ALL on board. I think we've always had challenges in the past wanting to do more of CAD, but having certain obstacles to be able to do that. So, yeah, this has made that much easier, especially that the course is able to be done online. Staff and learners don't need to necessarily come in and sit down for hours and hours on end. They can do it at their own time.
We just completed our second session, our first online. Last week we had a contact session. And the feedback I'm getting from all the teachers is very positive. They're like students again. Look, we do struggle, but we need to adapt. And we're doing it for our children because they need AutoCAD for the future. But in a nutshell, the experience and the feedback I'm getting, the learner management system, the online support that the teachers is getting, it's just all compliments from them. So yes, we're enjoying it, struggling a bit with some of the questions and tests that we haven't done in a few decades, but we're getting there because we need to do this for the children.
I found it very good. It made my life incredibly efficient, and it was a lot faster than doing instrument drawings. I really enjoyed it. Once you get to learn how to use like commands and stuff, it made life a lot easier than going to your taskbar and working that way. And then I even went online and found videos to improve my ability when I was using it.
At CAD4ALL, we teach graphics and communication. Amongst the students, this is quite an exciting module. This module also encourages students to use different media to express the projects which they develop. This often ranges from hand-drawn to digital graphics. Another key aspect is for students to engage with scale, which we often pair up with model building. It is a craft on its own, and it's a good way to derive a physical product for further demonstration.
One of the biggest features of the School of Architecture is that through our active industry engagement, students are exposed to professionals across the built environment disciplines. This gives our students an edge in the market, as our programs offer them with the necessary technical and professional skill sets that will enable them to flourish in the working environment.
The PG Bison Education Initiative is currently in its 28th year and was created to recognize future interior and architectural designers in the South African design industry. We are proud of our learners' achievements in reaching the top 10 finals in the PG Bison competition in 2019 and 2020.
So if you think about architectural technology awards you the designation of an architectural technologist. There are 9 categories of designation. So in the designation of categories, we have architectural draftspersons. That's the first. The second is an architectural technologist. The third is senior architectural technologist. And the last is architect. The qualifications that you need to achieve the designation for each of these categories. The first one for a draftsperson would be a national certificate in architectural technology. If you're looking at a technologist, you need to get a diploma. Also, a degree equates to someone becoming a technologist. If you're looking at an advanced diploma or an honors level qualification, you would then become a senior technologist. And if you do have a master's, you will then be an architect. And that's how the qualifications generally marry along to the designations or the titles. I hope this made some sense to you and was informative. And we'll talk a bit more about architecture in the future.
We are looking to equip our students with a mindset to grapple with the social, environmental, economic, and technological challenges which lie ahead. We take students through the process, from knowing little to nothing about the field, to being able to demonstrate the ability to engage with high-level technical and abstract concepts. Architecture has been viewed throughout the ages as milestones of a generation. That is why we do not only look to creating a new reality for students through our academic offerings, but rather creating an environment which allows the students to build a future for us all. It is for you, for me, for us all. Who are we? We are CAD4ALL. All right, so to everybody joining us online, thank you very much for being with us the whole day. So what we are going to do now for you online viewers, obviously you have been watching along with us to see all of the presentations that have been taking place, but we also want to give you an opportunity to see individually what each one of our industry partners who is exhibiting here with us today has to offer and why we have partnered with them to be here as well. So what we're going to do is we're going to go around partner to partner, and we're just going to see who each partner is, why they're here, and how they have this experienced this expo so far for the last day and a half. So we're just quickly getting a banner upright that just decided to blow over, and then we'll move over to our first exhibitor.
So we do, when we change colors, we do get like a transition reel.
All right, so first up we have Mrs. Agnes van den Berg over here. So she is representing the National Home Builders Registration Council. So Agnes, if you don't mind telling us just quickly about the NHBRC and how you've experienced this expo so far.
Thank you for the opportunity. The NHBRC is responsible for regulating the home building industry. That means that we have measures in place in terms of administration, as well as in contact with inspectors, to be able to ensure that the quality of the homes that are built will be of acceptable quality and standard. And at the same time, we provide a warranty to the new homeowners. A warranty that lasts for a period of 5 years from date of occupation.
And how have you experienced the expo so far?
Oh yes, that's the most important part. The reason why I'm here is because obviously I would like to expose the NHBRC to a new market. And a new market has come our way in terms of what I've been experiencing with the students, those people who are taking us forward into the future. And then at the same time, also met very, very interesting people with backgrounds in terms of architecture, but also in terms of the lifespan that they have been completing so far, and the fact that these people are very disciplined and they are very respectful of one another, and at the same time are very dedicated towards their own futures.
Fantastic. Agnes, thank you so much for your time and thank you for being with us.
Pleasure. Thanks,
we hope
Ryan.
you enjoy the rest of it.
Thank you.
All right, then next up over here, I'm just going to interrupt this gentleman over here. So next up, we have the president of the South African Institute for Building and Design. Now, President, if you don't mind telling us just briefly, quickly about CYBID and then also how you've experienced this expo so far.
Okay. Thanks, Ryan. Firstly, I think it's been a great privilege just to be in this environment and to get this opportunity from CAD4ALL to interact with what you guys do. I have been really inspired, especially by the technology part that you guys are bringing into the industry and through your students. And so I'd like to give you your accolades now for that. From the CYBID point of view, CYBID is a voluntary association. What we do is we represent architectural professionals. As most people who are professionals or in the architecture space will know that we have a regulating body that is SACAP.
Mm-hmm.
And what SACAP does is they look out for the public. we as CYBIT, a voluntary association, we look out for the architectural professionals. So we protect the professionals, whereas SACAP protects the public. So that's our main mandate as the VA. We somewhat like a union for architects, basically. And in that, part of our mandate is to educate and train our membership. And currently, we're on a drive, as I have discussed with the CAD4ALL team, to really recruit students to be part of our membership, because we see ourselves as CYBIT as the bridge between varsity and professional practice.
Yes.
And so we'd like to play now a bigger role in actually facilitating that journey for students moving from varsity into the industry.
Okay.
And so, yeah.
Fantastic. President, thank you so much for joining us here, and we hope you enjoy the rest of the time with us.
Thanks, Ryan.
Thank you. All right, then we're going to move over this way. So as you'll see here in the center, we've got some of our students' work on display as well. If you are watching, you might actually notice some of your work peeking out here through the table. But if you follow me, we're going to move to one of our next exhibitors here in the back. So over here, we have got Chart and Tinus from eCloud Construction. So Tinus, would you just mind telling us a little bit more about yourselves and then how you've experienced this so far?
Yes, thank you very much, and thank you for giving us the opportunity to come and talk to you guys here today. It's been a fantastic experience to seeing what's available by the university. We at eCloud Construction serve the building and construction industry by the eCloud Construction Network, which is a collection of online services that are designed to increase the productivity of professionals and anyone in the construction industry. We have a number of services that you can see here: the document access service, training services, software as a service, and also advertising and promotion that is available on our network. I can just, for example, we've got the document access service here, whereby we sell the JBCC contracts and also the Proxa contracts.
Okay.
And we are basically inviting the public companies to also come and place their content on our website, like contracts, CPD training material. For instance, we do under our training services, we've got we do webinars, and we also have a CPD on demand, which is an online service that is available 24/7 for professionals to obtain their CPD credits in their own time. So at the moment, we are running the CPD on demand service with the ACPM for construction project managers, SIA for the architectural profession, and also with CSAF for consulting engineers. So if you have any content like webinars, recorded webinars available, please come and talk to us, and we can put your content in the system, and we can market it, and you can also make it available to the building and construction industry in that way. Thank you.
All right. Thank you so much, guys.
Okay.
Enjoy it.
Good luck.
For the Expo discount code. So if you buy on our website, you'll get 10% off. Awesome, thank you. Yeah, Parliament going forward. Cool.
All right, then next up, I'm just going to interrupt her over here.
No
We've
problem.
got Jeanette, she's representing Emran. Now, Emran is one of the producers of 3D filament in South Africa, so they've got their beautiful product Zen on display over here. Jeanette, you mind just telling us a little bit more about you guys and how you've experienced this so far?
Oh, the show's been fantastic. We've really enjoyed being here. Love seeing all the students and how keen and eager they are to learn about 3D printing. We currently manufacture the Minima range and the Zen Ultra range, which is our more premium engineering grade. And we also do our own Emran in-house spoolless range, which you can print with reusable sides.
Okay.
So but it's been fantastic being here.
Great.
Been nice meeting all the students.
Awesome. Thank you so much for being with us.
Pleasure.
Enjoy it further.
Thank you.
All right, then right next to Emran, we have the people who use the filament that they create again. So we've got Netrim Technologies here with us, and with me is Jared Martins, one of the directors. So Jared, do you mind just explaining what is going on here in front of us and how you've experienced this so far?
So yes, as Jeanette said, she cleared it up pretty well. It's been amazing being here, meeting new people, throwing ideas around. 3D printing, we're here to represent the architectural engineering side of things, mechanical engineering, just showing off what 3D printing is about and what the capabilities of 3D printing. And from anything from, again, like I said, engineering, architectural, from the hobbyist to the industrial side of things. No limitations really at the end of the day. And yeah.
Great. And what are we printing at the moment?
So we're printing a little spaceman and we're printing a boat just to show off the prints. Yeah.
Awesome. And then if you can zoom in here as well, they've been so kind as to even show us what can be done with the architectural landscape in 3D printing. So you'll even see some 3D printed house models over there.
Cool.
Jared,
Great.
thank you so much.
Thanks, man.
And then over here at the left, we have Bernard from Nikon. So he is representing Nikon in South Africa. Now you may be wondering, how does photography come into this whole play? So CAD4ALL is launching a whole new range of photography courses. One of the main ones being a qualification in construction photography. And Nikon is one of our partners in bringing these courses and these qualifications into the curriculum for CAD4ALL. So Bernard, could you just tell us a little bit more about what we've seen here and how it's been?
Ryan, thanks very much for allowing us to be part of this amazing convention or conference. So, I come from a company called Premium Brand Distributors in South Africa. We proudly distribute Nikon for the last 20 years. And we've obviously appealed to many end users in terms of the photography aspect. In terms of architecture, yes, we've had a good history with people that have used our gear. And fortunately, Nikon is one of the preferred brands because of the lens offerings, the low light capabilities, and just the ability to do stuff, right the very first time sort of thing. So we have obviously embarked onto the mirrorless technology, which is now a step forward into the digital era where these cameras are quicker, better, sharper than ever, as well as much more compact in form factor, and then ease of use. Everybody wants to do things professionally, can just pick up this camera and get going. So there is no real studying to be done, except we give a guidance, we give an intro course to, which is what we're going to do with CAD4ALL, is to have a facilitator come through from time to time and just ensure that the students are using the gear effectively, and if need assistance, we are to help. And then we've also created a very special pricing structure for your students, because we do understand getting into this type of gear is expensive.
Yes.
So we put a 10% student support discount for you guys all the way through the year.
Thank you.
And we'll continue to work to help you guys.
Fantastic.
And thanks for having us once
Thank
more.
you. So there you guys heard it. If you are interested in any of this equipment, we will have all of our presenters and our exhibitors' details available on our Facebook page as well as our website. So be sure not to miss out on that opportunity. Bernard, thank you so much.
Pleasure, Ryan.
It's been great having you, and enjoy the rest of it.
Thank you, man.
So there you have it for everybody joining us online. That is our exhibitors at the 2022 Architecture and Design Build exhibition. Currently in the background, you'll hear our student cohort is here also talking to the exhibitors, seeing what all of these various industry partners have on offer. Excitingly, as I said, all of these industry partners play a key role in CAD4ALL, from the photography bringing into our courses, 3D printing being launched in all of our qualifications, the guys there from CPD, eCloud Construction, who are our partners when it comes to the engineering and the drafting to provide CPD and load all those courses online, to Cybid, where our students will soon be able to also register as members, and also validating all of the CPD workshops throughout this entire expo. And then, of course, the National Home Builders Registration Council, very importantly, knowing what is out there for the students when they are in not only the architectural landscape, but in the built environment landscape. So thank you very much for all of those who have been watching all day. It's been great having you online as well. Stay tuned. Coming up very soon at 5 o'clock, we will be having another CPD workshop presented by myself on upskilling architectural professionals for the 4th Industrial Revolution. So thank you very much, and enjoy the rest of the expo with us. All right, good afternoon, everybody. Am I on? Now I'm on. Okay. Thank you very much for joining us for the final workshop for the day. So as you can see on screen, what I'm going to be taking you through is a presentation on upskilling architectural professionals for the fourth industrial revolution. So for those joining online, my name is Ryan Woodward. I'm the manager at CAD4ALL Institute of Applied Architecture. I myself have also studied architecture, among a few other qualifications, which led me to where I am today. So for those that are online and do not know a little bit more about CAD4ALL, I'll get into the company CAD4ALL a little bit later. But what we are going to be focusing on today is various topics pertaining to the future of architecture, matters that we as professionals in this industry need to be aware of as we approach the next industrial revolution, because whether we want to know or not, it is on its way. So I'm going to get us started by ensuring that everyone is on common ground. And to do that, we need to know about BIM. So we're going to start with the evolution of BIM. Now, to understand BIM, we are first going to take way back. We're going to go back into the past. We're going to come to where we are today, and then we're going to go on to the future to where we are heading to. Now, you'll see this whole presentation. We're not going to have slides of words. I'm giving you certain keywords, and then I'm going to give you certain explanations about those keywords. Each word that I'm going to be presenting to you is going to trigger something in your mind. And at the end, we're going to have a conclusion. If you just excuse me, just going to put that aircon on. It's a bit hot here with the sun. All right, so the first one we are going to start with to understand the evolution of BIM is the Japanese soroban. So we are going to take a look at the idea of numbers, the abacus, and positional notation. So first of all, we're going to take a look at numbers. The numbers, as you might know, come from the Indo-Arab system, coming first from the Far East, moving on to the Middle East, and eventually onto the West. As you'll see on the slide over here, we're depicting quite a few different notations that were created, eventually leading up to the ones that we know and the ones that we are most familiar with today. So this idea of recording numbers has been around for centuries, and perhaps one of the most easiest ways to store numbers is actually through an abacus. Now, an abacus is something that we all know from our childhood, and the one that you are seeing on screen is actually a depiction of the soroban. Now, the soroban, or the Japanese abacus that you're having a look at, stored and transferred information. It essentially stored and transferred this information by someone simply moving up and down the beads of the abacus. If you look now at the top row, you'll see that over there, that is the number 5. So every time you count, you'd go 1, 2, 3, 4, and then obviously 5 is at the top. So then you'd start again, 5, 1, 2, 3, 4. 4 is now at the top, 4, 5, 1, 2, 3, 4. So you go on and on and on. A little bit more complicated than how we count these days. And I know as children, we just used to move the beads up, down, up, down, up, down, and we had 1, 2, 3, 4, 5. Okay, but every time this happened, we were storing information and we were transferring information. Every time we count a bead, we're storing it. Every time someone reads off the number on the abacus, we're transferring information over to someone else. So now on the next slide, what we see is the idea of numbers and how we can store numbers that are greater than 1. Okay, we've now seen an example of 1, 2, 3, 4, 5, but we need to look at numbers that are larger than 1, because remember, before we get to 2, there's 100 different iterations of 1 comma something, something, something before we get to 2. And that is what we see. Sorry, I've now gone a bit ahead of it myself. So that is what we see over there. Let's just get back there. Okay. So the notational system using the decimal or the comma, as we can see there, 1, 0, is quite an important factor in how we do that. But what else is really important about the idea is the 1 and the 0 is the dichotomy. And that leads us to part 2, which is binary. Now, has anybody heard of binary before? Okay, binary, we usually hear about it when we're talking about coding. So in the word binary, we're going to refer to a relationship of 2. We're going to look at the Gutenberg press, the codex, as well as screen printing. Now, all of us who have studied architecture or who are currently studying architecture, we should know this, but everybody has a different take on it. And I'm going to give you a take that we have developed. So by moving on to the next slide, we are all familiar with this. 1, 0, light and dark. Where do we see 1 and 0 every day? There we go, on a light switch. Okay, essentially that's all that 1 and 0 in binary means, on and off. Every day we're working with binary, we don't even realize how many times it comes forth in our daily lives. So there you see on, off, or true and false. And that's basically really what the foundation of computers are. But I'm not going to get ahead of myself because computers, that's already coming into the future. We're now still back there. We were working with abacuses and we've got the notational system. So we're going to move first into printing. Okay. Now remember I said there are 2 qualifying factors to ensure that a computer actually qualifies as a computer. It must store information and then it must transfer information. Now there's many different ways today where we can actually do that. We've got printers, we've got email, we've got all of those different kinds of things. But in the olden days, we started off with the Gutenberg press, all the way back there in 1440. Okay, so the Gutenberg press it allowed people in society to actually gain access to documents that they didn't have access to otherwise. Think about it. Only the high society was able to obtain, if you are a fan now of the Bridgerton Lady Whistledown, only the highest in society was able to get hold of that newspaper. And this Gutenberg press allowed that these high society documents and what was considered sacred documents were now able to be mass reproduced to the public. And that is where some of the first books came into play, or as we would have known them back then, a codex. Now what you're looking at over there is actually pictures of some of the oldest books in the world, back then known as a codex. And these books were actually photographed by our program coordinator, Akil. So he actually saw these books when he visited Abu Dhabi. So there is actually a record of some of the oldest codex in the world. Okay, but now this idea of storing and transferring information, we've seen the Gutenberg. Now we're going to take a look at screen printing. Now we all know screen printing, obviously our t-shirts that we wear, hoodies, you know that screen printing takes place on there. So screen printing, essentially someone strikes, when they take the ink across the screen, they strike the ink and it pushes it through a screen. And in that screen, there are thousands of little holes which eventually allow that ink through. And when you've put all those different layers of ink on, you come out with a completed image. That's once again, information was stored on the screen. Information is transferred with the ink onto your material. Now we're used to it being clothing. Back then, they used screen printing as a different version, once again, of our photocopier machines. So screen printing was used to mass reproduce documents again. Now, that was the old. Now we're moving a bit more into the new. So part 3, we are now going to take a look at computers. And now we are going to specifically focus on the revolution of computers. Okay, how we store and transfer information in the way that we understand a computer in the day, or as we see it today. So what we're going to talk about is the punch, we're going to talk about CTR, and we're going to talk about the sketchpad. Now, I know you're thinking, I've already jumped over 5 different topics. Where is this going to end up? But trust me, when I get to the end, it's all going to make sense. Okay, so right here, I have a computer in front of me. Here we have a desktop computer. Way back when, computers would have filled this room with a hard drive of what, like 10 megabytes, and that was fantastic. That was a lot of data. Now we all have computers in our pockets. You don't even need the computer in front of me. But it started from somewhere to get us to where we are today. Once again, a different example of a revolution. In all these forms of technology, revolutions have taken place to get us from where we were to where we are, to where we're going. If you are a fan of Apple, you would have watched the new Apple event that came out a few weeks ago, and you see what is possible with a phone now. You don't need a laptop, a camera, PDA, and all of those things. It's all in this little device that can be held in your hand. Okay, but where it all started was the punch. Now, your parents might remember the punch when they used to go to work. You would clock in with a little punch card. Essentially, it's a card, goes into the little slot, and then it punches a hole through. And when it punches the hole through the card, it's also recognizing on the back. So it's registering that it's actually pushing through. Because some people might have tried to push, I don't know, a piece of toilet paper in there if they didn't have their card on them or something, but it needs to recognize that it's actually punching a hole through. So it's storing and transferring information once again. There we see it happening. Okay, so that was the punch. Then we move on to a company known as CTR. Does anybody ever heard of CTR? You might know them better as IBM. Okay, so IBM used to be known as CTR, and they are the oldest creators of computers. If we take a look there, you can see one of the first examples of their desktop computers that they created. Now, you don't even see a little space there for the floppy or the stiffy disk there. So you can see just how old these computers are. But once again, storing and transferring information. We enter information on a keyboard, it goes in, it gets stored, and it gets transferred either by printing it out or nowadays, like I said, by emailing it or however. Okay, but it was stored in something that was called memory. Now, the way it would translate the information, that we know as a compiler. But with that, many people were experimenting with this and how we represent this information. So if you take a look at the compiler and how we represent the information, you usually use zeros and ones. Once again, going back to the code of binary 0, 1, representing other numbers as digits on a computer. But if you can figure out digits and how they make coordinates on a system, a computer, a screen, then you can do something like Ivan Sutherland. And that's that gentleman over there. And he did it with his very famous sketchpad. So that's what you can see over there. Now that sketchpad, our modern children today, you should recognize that almost something similar to your Expo sketch you had as a child. You know, that little board and you draw and then you slide and then it blanks it out. So that's essentially something similar to what Ivan Sutherland created way back when. That was actually one of the first examples of a digital interface system that was created by Ivan Sutherland. And this is also one of the key integral parts that led to the creation of CAD. And that is where we all obviously come in with CAD. So in part 4, we're going to move on to CAD. Okay, now with CAD, I'm going to talk about 2 of the leading competitors. We're going to take a look at Autodesk. We should all know Autodesk. And then we're going to take a look at how Graphisoft came about. Now, as you might know, Graphisoft, coming from the word graphical software or graphics, they created software to do this very same thing, represent visual diagrammatic geometrical ideas instead of just numbers and letters. So we've moved on from seeing just representations of numbers and letters. Now we're actually seeing a visual representation on our screen of how all that 1 and 0 produces something. So they started to create some of the first software, but then, of course, their rivals, as in anything, comes in, and we have Autodesk, who we all know today. So Autodesk later came up, and they almost bettered their systems, if we could say that. And much to a large degree, they also improved the systems. Now, these were CAD information systems. They were all 2D, and they were all 2D operating systems, because that is what CAD essentially is. It's a 2D operating system that we're all working on. But we are now moving into the future. We're moving into 3D, and we're moving into BIM. And that is where we come to Autodesk's Revit, which is something that all of you guys have definitely been working on. So Autodesk Revit, it revises stuff instantly. It creates 3D models, and Graphisoft's ArchiCAD makes architectural CAD drafting into some sort of objects. So those were our 2 main competitors that we had. Now, over the years, obviously, these 2 have been contending with each other. And as you can see from the word Revit, if you didn't know where it came from, Revit actually means revise instantly. Because what are you doing in 2D, it automatically pulls it up in 3D. Whatever you change in 3D, it automatically changes in 2D. So that's essentially where Revit, the name, came from, because whatever you do, it's revising it instantly, constantly in the background, storing and transferring information. Okay, but I'm not going to talk, I am actually going to talk about revising instantly, Revit. Getting a bit ahead of myself again there. Because when we make a change on the floor plan, like I said, it's obviously going to do the same thing on the section, on the elevation, and all of that. And that is because of parameters. Okay, once again, another word I'm throwing at you. So the next part we are going to take a look at is the parametric paradigm. And this comes from the word parameters. Now, a paradigm in the idea talking about our world views or views of the time where we came to now, only one, say, 500 years ago from the Renaissance period, the only way that we could convey these information accurately to a contractor to draw was through orthographic projection systems. Okay, now I'm looking at you guys. Who's the creator of this system? Who formalized it? What was his name? Other way around. Gaspard Monge. Okay, there we go. So Gaspard Monge officially formalized the orthographic projection system. Now, if you have a look at it, the projection system is really about taking an object and representing it through lower levels of abstraction or higher levels of abstraction, as might be alluded to. In other words, simple layman's term, it pushes or pulls a surface and a plane. So we're taking a 3D object and we're pushing our planes out into a projection so that we can see the different views thereof. Now, you can use that to compress information and build buildings from there or build objects from there, or once again, storing and transferring information. Now, again, another type of computer has been described. Every time this is happening, no matter where, it's a type of computer. Remember, your brain is also a computer. It's constantly storing and transferring information. But then we came to a time where these guys came in. We have SketchUp. Okay, now I know a lot of you guys actually prefer using SketchUp to Revit, even though your lecturers despise SketchUp and they want you to work with Revit. But obviously, we all had to start somewhere, and SketchUp was one of those people who came in there. Now, SketchUp is where you don't really need to work with that much information. You don't really need parameters. You can just push and pull information up and down, and you can add your materials. You can make it all fancy and look nice and snazzy. Okay, but 3D, obviously, where we are moving to today, we need to take a look at something that can do a little bit more, and that is obviously Revit and parameters. So in some of these softwares, they're quite sophisticated, and they allow us to do buildings like these. Now, the building you are looking at over there is Zaha Hadid's Haydar Aliyev Center. And the software that they used allowed you to design more complex architecture like this. Obviously, you can see those sweeping facades. There's not very many straight lines. Can you imagine doing something like that on Revit? On SketchUp, sorry. I would give you an award if you can do that for me in the time on SketchUp that you can do it on Revit. Okay, but what allows us to do this is parameters. And that's what we are going to take a look at. What is parameters? Okay, so parameters are, let me get on to the next one. Sorry, I've gone ahead of myself again. Okay, parameters are what you can see over there. So you all that have worked on Revit, you should be familiar with this screen. Okay. So parameters allows us once again to input information, and it's giving us something visually in return. Okay, so those parameters are acting like a programming language. We're programming the software to give us an output that we want. Now, there are many different types of software that can do that. Revit is one of them. Dynamo is another one. Rhino is another one. Grasshopper, all of those contenders. They're all different ones that can use that programming language and actually pull out something like that. I see you looking very confused now. Don't stress. I'm not going to test you on this. Don't worry. Okay. There you can see. That is what it would look like. So from putting it into that is what we would see graphically. We're entering in these parameters, and that is a graphical representation of how it would lead us to actually get a building. Now, what you see on the next slide, it may look like pretty regular houses, probably somewhere in Poland or Sweden or somewhere where they like to do those concrete house structures. It looks pretty regular, like I said. But if we take a look at the next slide, you'll see that there's actually quite a lot that goes into getting that. What is one of the most important things that your lecturers teach you when you're designing a house? Natural light and? Okay, more about energy. What is one thing that council always looks at? What's the one calculation you always need to do? And fenestration. There we go. And that is what you're going to see on the next slide. So by inputting a host of various different parameters, these softwares now allow you to get the best result. So in the past, we would have had to draw up all these various different iterations until we finally got to the one that we needed. Now we simply go input all of these parameters into a computer, and it'll show us hundreds of different iterations of what the best one is to get what we need. So there you can actually see a graphical representation of how large the windows in the building need to be for the optimal energy efficiency, allowing enough heat in the winter, and obviously not keeping the place too hot in the summer. Okay, so it's a kind of form of artificial intelligence because it's actually doing something. We're giving it the information, but it's actually going to go do all this on its own. We're just giving it the little foundational steps. It doesn't actually need us to do this. It can actually do this all on its own. Okay, and that all comes down to generative design. And that is something that is going to be very key in our qualifications going forward because that is an integral part of the fourth industrial revolution. Now you can see the very different softwares like I mentioned. There's Rhino, there's Grasshopper, there's all of those. But where we are coming to today, where it's very much being formalized, is in what is known as Project Refinery. So there you can see a nice little diagram showing us where we came from 2D drawing, parametric modeling, into our Revits and our Dynamos, and now we are moving into the future, which is generative design. And Project Refinery is actually Revit's go-to at that. It was their trial run, but now it is actually being included in all of the Revit software going forward. So from next year, when you start working on Revit, you're actually going to get a generative design function in Revit. And what that is going to allow you to do, it is going to allow you to create these undulating and flowing structures like Zaha, Diz Aliyev, Haidar Center that you saw over there. And if we take a look over there, that is where it's coming into. And that is why we are also introducing 3D printing into the qualifications. Because generative design is going to allow us to create these kinds of things. It's going to allow us to create structures that never would have been possible if we didn't start from binary, screen printing, codexes. All of that stuff led us to where we are over today. Now, I know you've seen out here 3D printing. You've seen all the fantastic things that they can do. But look at what generative design can do. We all know that they've already started printing 3D houses. If you don't follow those channels, do yourself a favor, go check those things out where they're actually 3D printing houses. But take a look at something like this. Okay. So there's an iteration of something that has been 3D printed. That over there, that's what's needed. That over there, that's what we design. Obviously, we as human beings always want something that's going to look beautiful. It needs to be fancy. We want to show off. It must look smart. But we're forgetting about the function. That's all that's actually needed in this component. But we need to go and add all that makeup on top of it to go and make it look fancy and smart so we can post pictures of it on social media. Okay. Like I said, that's all that we need. And all of these things are coming down to things like generative design and 3D printing, which is the future of our industry. Now, like I said, there are many different types of things that allow us to do that, but computational design through generative design is what is going to allow us to do that. Now, speaking about houses that are being 3D printed, take a look at this. Okay, that's pottery. That's actually been 3D printed. So they're actually 3D printing with clay. How was that done? When someone asked the lady on her TikTok channel, I use whirly noise algorithms in Grasshopper, a visual programming language plug-in to Rhino, aka generative design. That is the future towards what we are heading to. Okay, now the reason I've been spilling out all of these different types of words, and it's something that you guys sitting in front of me and also a few of you students that have been watching online have been hearing a lot, but that leads us into where CAD4ALL's new qualifications are going. Okay, so that is the CAD4ALL solution. Now, you all know that CAD4ALL is moving away from our old qualifications in architecture and drafting, and we're moving over to new qualifications. All of these new qualifications are including generative design, 3D printing, Dynamo, BIM, Revit. You saw Lano give a Maya representation demo this morning, Fusion 360. All of these new softwares that are going to allow us to do these things are are coming into these qualifications. Like you saw this morning, Mr. Van Wyk that was talking, who was one of the co-contributors of those qualifications. You see, everything is pointing towards the future. Yes, we need to look at where we came from, but we need to know where are we heading. And the future is going to happen whether we want it to or not. Okay, so what we are doing here at CAD4ALL and what we are offering you is the solution that you are going to be able to be relevant when you get out into industry. Because it doesn't help we teach you something and you're going to go out into practice and then everything changes and you've got no idea what we're talking about. Okay, so that's where we're coming in with the qualifications. So you obviously know Architectural Technology NQF6 and launching our Architectural Technology NQF7. And this is the one that is aimed at the fourth industrial revolution. So all of you guys that are going through Architectural ND, you're doing your practical years, that's where you are aiming towards, to get into these qualifications so that you can be relevant and practical when you get out there. But like I said, these aren't the only qualifications. We're also revamping. And I know you know this, but remember, there's people online who haven't heard all of this before. So obviously, we have revamped our schools. So we've got the School of Architecture we took a look at, and Interior. And then we've also launched a whole lot of new qualifications. Now, you'll see this morning a message was sent out to you guys to also pay very much specific attention, not just to 3D printing, but to photography next to that. And this is one of the reasons why. So there you'll see the School of Drafting, the new ones coming in, mechanical drafting. You'll see construction tech, construction estimating, health and safety officer, and even construction photography, which is why I said that photography is coming in. Okay, so once again, all of these qualifications, making sure that you are prepped and ready for the future. Then very importantly for our corporates out there, we obviously offer the short courses, Autodesk, Revit, Inventor, AutoCAD, sorry, and then Maya, Fusion, 3D printing, all of those also launching soon. And obviously you can do your international examinations. Okay, so to sum it up, where we came from, we had to start with coding. We had to start with ones and zeros, ons and off, true and false, went into things like screen printing, mass producing books, all of this storing and transferring information, coming to CTR to IBM, which allowed us to design our very first graphical user interfaces for CAD through the Ivan Sutherland system, moving on to Gaspard Monge, and then we could get into where we are today with 2D CAD, 3D CAD, and now where we're moving on to BIM, and where we're moving on to generative design. Okay, and that is all from me. Are there any questions? I can see you all look so confused.
I don't have a question.
Yes.
I just want you to, if you go back to the Gutenberg press of 1440.
Yes, let's get back there.
A few slides back. Whether you have noticed how similar it looks to a 3D printer.
Yes, very much. You're very correct. Let's get back there. There we go.
Still looks the same.
Very much. So there we've got our flatbed, and there we've got our controlling arm. Okay. You didn't think of that, did you, Shati? Okay. Yes, Ryan. I personally prefer, I started obviously working on Revit. I've looked at the others like Dynamo, Grasshopper, all of those. It's going to depend on person to person. Obviously, as someone who's been trained on Revit, I will stick to Revit. I like to experiment with new products. I like to see the new ones. With the new qualifications, we are going to be exploring new ones like Dynamo and Rhino and all of that. So it is definitely something. Me personally, I still get scared looking at things like that, even though it is the future. But it's scary to think that we will be able to enter information into a computer and it will be able to give us something like that.
So then you think that it would be best for students to start learning how to use this stuff as soon as possible?
Definitely. Like I said, be relevant. If you want to go work for those big firms, you need to be relevant. You need to know where we are moving towards. Yes. You can speak a little bit louder.
All these generative design capabilities,
Yes.
all
Yes. So from 2022's version, you'll see when we allocate your license, it always says Revit and 14 components, or AutoCAD and 14 components. So for instance, in AutoCAD, you get access to AutoCAD, architectural, MEP, surveying, construction, all of that. Now with Revit, you're going to get the same. You're going to get standard Revit architecture. You're going to get standard Revit BIM, Revit generative design, all of that. So that all gets included in your student packages. Okay. Thank you very much.